Hello everyone, welcome back to Maths Marathon classes. This time I'll be doing application of integrals of KCET. For 42 years question papers I'll be covering PYQ series from 1984 to 2025. We know that CET started in the year 1984, so application of integrals was included from that 1984 itself. So we got 42 years PYQs. So for our new viewers, I'm telling you that I have covered already a differentiation chapter, application of derivatives and definite integration of this series, KCET 1984 to 2025, this series, okay. This is my fourth topic under this. Also, I have covered JEE mains of 2025 and 2024 of some topics, okay. You can watch those videos. In the coming days, I'll be uploading more and more number of videos. Even synopsis part of our KCET and JEE, both I'll be doing separately. Okay, even important questions for board exams of second PU as well as first PU will be covered in the coming days. Okay, please subscribe to my channel and forward to your friends so that you can make maximum use of this Abhiram's Maths Marathon YouTube channel. Okay, we'll see the weightage of this chapter. Historically, number of questions appeared from different years, one by one. Okay, and also we'll cover the concepts. Okay. Application of integrals. I'll be explaining the concepts also while solving the problems. Concept wise I'll be doing it. That's the main important thing, so that it is beneficial for you. Okay. So number of questions appeared from different years. In 1984 they asked 2 questions. No questions were asked in 1985, 86, 87, 88, 89, 90 each 1 question. 91 1 question. 92, 93, 94 each 2 questions. 1995, 1996, 1997, each 1 question were asked. No questions were asked in the year 1998, 1999, 2 questions, 2000, no question, 2001, no questions, 2002, 2003, 2004, each 1 questions were asked. Okay, so next we'll see 2005, 2 questions, 2006, 2007, 8, 9, 10, 11, all, each 1 question then. No questions were asked in the year 2012, 13 1 question, 14 2 questions, 15 1, 16 1, 17 18 both 2 questions, 19 2 questions, 22 questions, 21 2 questions, 22 1 question, 23, 24, 25. Last 3 years they're asking 2 questions in every year. Okay, so on an average we can tell 1 or 2 questions will be asked from this chapter. Can't neglect this. Okay, it's a quite important chapter. So application of integrals. We'll be finding area under the simple curves and area between the 2 curves. Actually, area between 2 curves is deleted now at present from the NCERT book. You can see only one exercise in the NCERT textbook, 8.1, and there is one miscellaneous exercise. Earlier we had 8.1, 8.2 and miscellaneous exercise. Okay, area between 2 curves is deleted for KCET as well as for board exams. But I'll be covering both the area under the simple curve and area between the 2 curves. Even the deleted part also I'll be doing it. Okay, so it will be useful for many other competitive exams, because students nowadays not just write one exam, right? They write many competitive exams. So it will be useful whenever you write many other exams like NDA or JEE. This will be useful, even though it's deleted. You need to learn it. Okay, for knowledge. And one more thing is that you should know how to draw the curves. Like y equal to x square, y square is equal to x, y equal to mod x, such curves, y equal to 1 by x, log x, e power x, sin x, cos x, all those things. I'll be drawing the simple curves, okay, to make you understand. So I'll start with the basics of this. Before going to the problems directly, I'll draw those curves, okay. So to make you understand, the different parabolas I'll draw, and also the modulus functions, all those things we'll draw first, and then I'll work out the problems based on this. Okay, I'll add one page here to draw the curve y square is equal to x. Y square is equal to 4x. I'll start first. Y square is equal to 4x is the parabola having the vertex at origin and axis is along x axis. The symmetric with respect to x axis. Y square is equal to 4x takes this form. Y square is equal to 4x. Vertex is at origin. Axis is along x axis. This is y square is equal to 4ax, and a is positive. You must know that a is positive. If a is negative, it will be opening on the left. This is called as a right-handed parabola. Okay, the vertex is at origin and axis along x-axis. If you take y square is equal to 4ax, where a is negative, the parabola will be opening on the left. This is called as left-handed parabola. This is called as the left-handed parabola. Y-axis, x-axis. This is y square is equal to 4ax, where a is negative. A is negative. Here a is positive. Okay. So I'll draw particular cases of this. Y square is equal to x. Y square is equal to minus x of this things. If you want y square is equal to x, it is like this. Y square is equal to x. The parabola having vertex at origin, axis along x axis. Y square is equal to x. Vertex is at origin. If you want y square is equal to minus x, it is like this. Y square is equal to minus x. This is y square is equal to minus x. Vertex is at origin. Y square is equal to x minus 1 is like this. This is y square is equal to x minus 1. The vertex will be at 1 comma 0. Vertex is at 1 comma 0 like this. Y square is equal to x minus 1. In general, the parabola y minus k the whole square is equal to 4a into x minus h. Y minus k the whole square equal to 4a into x minus h has vertex at h comma k. Has vertex at h comma k. You must learn this. Okay. The shifted form of the parabola. Okay. If you want, you can write y square equal to x minus 1 as y minus 0 the whole square is equal to 1 into x minus 1. Correct? Y minus k the whole square equal to 4 into x minus h. Compare vertex h comma k, that is 1 comma 0. So vertex is 1 comma 0. Y square equal to x minus 1. If you want, you can draw y square is equal to x plus 1. That will be having vertex at minus 1 comma 0. So also you must be knowing how to shift the parabolas. Okay. Y square is equal to x plus 1 if you want. Y square is equal to x plus 1 like this. Y square is equal to x plus 1. The parabola whose vertex will be at minus 1 comma 0 like this. Vertex at minus 1 comma 0. Can write y square as y minus 0 the whole square, x plus 1 as x minus minus 1. So vertex at minus 1 comma 0. The parabola y square is equal to x plus 1. If you want, I can draw from y square is equal to x, I can draw y minus 1 the whole square equal to x. Shifting it. Y minus 1 the whole square is equal to x. How to draw? Y square is equal to x for like this. Y square is equal to x is here. Correct? Has vertex at 0 comma 0. If you want y minus 1 the whole square is equal to x, y minus 1 the whole square is equal to x means 1 into x minus 0. This is y minus 1 the whole square equal to x. The vertex will be at 0 comma 1. Vertex will be at 0 comma 1. 0 comma 1 lies on y axis. Like this. Vertex will be at 0 comma 1. 0 comma 1 is here. The vertex will be like this. Somewhat like this. This is vertex at 0 comma 1. And if you want y square is equal to x, y is equal to x square next. Y is equal to x square like this. Y equal to x square. The parabola like this. Y equal to x square like this. Symmetric with respect to y axis. If you want y equal to minus x square like this. Y equal to minus x square. The inverted parabola opening downwards. Y is equal to minus x square. If you want y is equal to x square plus 1, it's shifted 1 unit above the origin. Y is equal to x square plus 1 like this. The vertex will be at 0 comma 1. Y is equal to x square plus 1. The vertex is at 0 comma 1. When I put x equal to 0, y equal to 1. If you want y equal to x square minus 1, it is shifted 1 unit below the origin like this. Y equal to x square minus 1 like this. Y is equal to x square minus 1. It is going to be shifted 1 unit below the origin. The vertex will be at 0 comma minus 1 here. This is the vertex at 0 comma 1. Okay. All these things you must learn. If you want, I can draw from y equal to x square. I can draw y equal to x minus 1 the whole square. Y equal to x minus 1 the whole square I can draw. Y equal to x minus 1 the whole square. Y equal to x minus 1 the whole square. You can write this as x minus 1 the whole square is equal to 1 into y minus 0. You can compare this. X minus x the whole square equal to 4e into y minus k. This parabola has vertex at h comma k. H comma k. Vertex will be at 1 comma 0. Something like this. 1 comma 0. The parabola is. Vertex is at 1 comma 0. And in general, remember that this is y equal to x minus 1 the whole square, the parabola. If you want y equal to x plus 1 the whole square, it will be like this. X plus 1 the whole square like this. Y equal to x plus 1 the whole square. This is vertex at minus 1 comma 0. Y equal to x plus 1 the whole square. X plus 1 the whole square. Vertex at minus 1 comma 0. Okay. So all these things you must know. In general, I can tell you that y equal to ax square plus bx plus c is going to be a parabola. And if a is positive, okay, it's going to be opening upwards. It's upward parabola, I can tell. And if a is negative, it's a downward parabola. A is positive and D, the discriminant is going to be positive. In that case, the curve looks like this. It's an upward parabola like this. Y equal to ax square plus bx plus c. Okay, quadratic in x. Y as a quadratic function of x. Okay, in that case, it's going to represent a parabola. If a is positive, it's opening upwards, and D is positive are taken so that it intersects the x-axis at 2 points. Okay, and if y is equal to ax square plus bx plus c, if you take ax square plus bx plus c, if a is negative and D is positive, D is the discriminant of the quadratic. Okay, in that case, it is going to be opening downwards like this. Opening downwards. A is negative means opening downwards. A is positive means opening upwards. The two parabolas you must know how to draw. Okay. The points where intersects the x-axis means that at that point y will be equal to 0. So you can find out these points. Okay. By putting y is equal to 0. Any point on x-axis means y coordinate is 0. So I have drawn the different parabolas. I'll be drawing next I'll be drawing the modulus function and also log x, e power x, 1 by x square, and even the circle, ellipse, semicircle, x mod x, all those things. Okay. So y equal to mod x like this. Y is equal to mod x. Y is equal to mod x is like this. V-shaped graph, symmetric at x equal to origin. At x equal to 0, it is symmetric. Y is equal to mod x. If you want y equal to mod x minus 1, it is like this. Mod x minus 1. This is y equal to mod x minus 1. This is y equal to mod x minus 1. If you want y equal to mod x plus 1, it is like this. Y equal to mod x plus 1. Symmetric at x equal to minus 1. This is y equal to mod x plus 1. Sorry, this is x equal to 1, no? 1 comma 0. This point is 1 comma 0. This point is minus 1 comma 0. This point is 1 comma 0. This point is minus 1 comma 0. Mod x minus 1. Mod x plus 1. Y equal to mod x. If you want y equal to minus mod x, I can draw. Y is equal to minus mod x like this. This is y is equal to minus mod x. All these things on modulus functions. Okay. If you want to y equal to mod x plus 1. Mod x plus 1 is like this. Y equal to mod x like this, no? From y equal to mod x I can draw y equal to mod x plus 1. This is y is equal to mod x plus 1. If you want y equal to mod x minus 1, it's like this. Y equal to mod x minus 1. This is y equal to mod x minus 1. Okay. Y equal to x square I drawn. If you want, I can draw y equal to x square I drawn. No? Y equal to minus x square I drawn. Correct? Everything is done here. So many curves I drawn for you. Correct? This is on modulus function. Various curves I am drawing on y equal to modulus function. If you want, I can draw y equal to x power 4. Y equal to x power 4 is like this. Y equal to x power 4. The shift like this. I mean, so narrower it is. much narrower. Y equal to x power 4. Y equal to x cube is like this. Y equal to x cube extends indefinitely downwards, indefinitely upwards. Y equal to x cube. This is y equal to x cube. Okay. Next I'll be drawing y equal to 1 by x mod x, all these things. Y equal to 1 by x like this. Y equal to 1 by x. Y equal to 1 by x. This curve is y equal to 1 by x. If you want y equal to 1 by x square like this, y equal to 1 by x square. This is y equal to 1 by x square. If you want y equal to log x like this, it passes through the point 1 comma 0. Correct? Log x will pass through the point 1 comma 0. Is y equal to log x. This curve is y is equal to log x base z. If you want y equal to e power x will pass through the point x equal to 0, y equal to 1, 0 comma 1, it always passes through. Y is equal to e power x, like this. This is y equal to e power x, passes through the point 0 comma 1. This point is 0 comma 1. If you want y equal to e power minus x, I can draw. Y is equal to e power minus x like this. It's e power minus x. Y equal to e power minus x. Both e power x and e power minus x will pass through the point 0 comma 1. This point is 0 comma 1. Correct? And if you want, you can draw y equal to x mod x. Y is equal to x mod x like this. X mod x. I can discuss two cases. Mod x means it is x for x greater than or equal to 0. X into x becomes x square. And for x less than 0, we know that mod x is minus x. X into minus x is minus x square. We can draw the curve for this. Y equal to x mod x. Y equal to x mod x, something like this. Y equal to x square and y equal to minus x square. Y is equal to x mod x. Okay, all these things you must learn. Y equal to x mod x means y equal to x square for x greater than or equal to 0. For x less than 0, it is y equal to minus x square. And y equal to root x also I can draw. Root x. Y is equal to root x. Y is equal to root x like this. Y is equal to root x. This is y equal to root x. Y is equal to mx is the straight line passing through the origin. Y is equal to mx. Y is equal to x in particular. Y is equal to x. Straight line passing through the origin. Y equal to mx. M is positive means it passes through the origin, bisects the first and third quadrant. If m is negative, it is not bisecting. It passes through the origin and lies in the first and second quadrant, the first and third quadrant. Y equal to mx if m is positive. Y equal to x bisects the first and third quadrant. Y equal to minus x will bisect the second and fourth quadrant. Y equal to minus x is going to bisect the second and fourth quadrant. This is y equal to minus mx. This minus y is equal to minus mx. And to draw the straight line, we require minimum 2 points. Taking 2 points on the line, you can draw the straight line also. Okay. Many other curves. If you want y equal to sin x, y is equal to sin x like this. In the interval 0 to 2 pi I am drawing. This is 0, pi, 2 pi. Maximum value of sine function is 1 and the minimum value of sine function is minus 1. Y is equal to sin x. And if you want, I can draw even the circle x square plus y square is equal to a square. Circle has center at origin, radius is a. X square plus y square is equal to a square. X square plus y square is equal to a square. Ellipse like this. Ellipse has major axis along x axis. X square by a square plus y square by b square is equal to 1. where A is greater than B, major axis along x axis, and y equal to root of a square minus x square is going to be a semicircle. Y is equal to root of a square minus x square represents a semicircle in this. Y equal to root of a square minus x square, semicircle, like this. Y equal to root of a square minus x square. So semicircle. X square plus y square equal to a square represents a circle. Okay. X square plus y square equal to a square represents a circle. Whereas y equal to root of a square minus x square represents semicircle. Area of circle we know, pi a square. Area of ellipse is pi ab. All those things you must know. Okay. So many of the curves are drawn. Okay. This represents semicircle which lies in the first and second quadrant. If you want y equal to minus root of a square minus x square, that lies in the third and fourth quadrant, the lower half of the semicircle. This is the upper half of the circle. So upper part of the circle is a semicircle. Lower part is not there for a circle. Okay. So area of the semicircle is half into area of the circle. So all those things you must know. Various curves are drawn. Root x, y equal to minus mx, where m is positive, or y equal to minus x, I'll take care. Y equal to minus x, I'll take, so that it is bisecting the first and third quadrant. I mean second and fourth quadrant here. Here it bisects the first and third quadrant. Here it bisects the second and fourth quadrant. Okay. If it passes through origin and it lies in second and fourth quadrant, means it is having negative slope. If it is passing through origin and it is lying in the first and third quadrants, it is having a positive slope. Correct? All these things are drawn. 1 by x square, log x, e power minus x, x mod x. Various curves are drawn. Connected to modulus function, connected to the parabola, correct? Various things. Coefficient of x square is negative, coefficient of x square is positive. In both the case, the discriminant is positive. Okay? Various curves are drawn here. Please make a note of this. It's a very basic concept. How to draw the curves you must know, so that it becomes easy to work out the problems on this. Now I'll take the PYQs. We'll begin with the questions now. After drawing so much of curves, area bounded by the simple curve. The concept is whenever they give curve y equal to f of x, you want to find area bounded by this curve between the lines x equal to a and x equal to b. X equal to a, x equal to b are the vertical lines. Equation of a vertical line is x equal to constant. X equal to constant means vertical line. Want to find area between x equal to a and x equal to b and the x axis. So area bounded by this curve between x equal to a and x equal to b and x axis. Want to find this area. Okay. In that case, we need to find area of this one rectangle. Okay. Take a rectangular strip, vertical strip. Area of that rectangle is y dx. Y is the length and dx is the breadth. And this area can be, area under this curve can be divided into large number of rectangles, infinitely many rectangles. Area of one rectangle is y dx. Area of rectangle we know, length into breadth, correct? So for some of the areas of all the rectangles will give the area under the curve. So if you want to find the sum of the areas of all the rectangles, we need to integrate it from x equal to a to x equal to b, y dx. That is what we have. Okay. So x equal to a to x equal to b, y dx. This is a formula given here. X equal to a to x equal to b, y dx. Y is f of x dx. Similarly, in the curve is given like this, x equal to g of y. Want to find area bounded by this, x equal to g of y, and the lines y is equal to c to y is equal to d with respect to y axis. In that case, we take a horizontal strip like this. X dy is the area of one rectangle, and this area under this curve is divided into large number of infinitely many such rectangles. Sum of the areas of all the rectangles will give the area under this curve. X equal to g of y, from the line y is equal to c to y equal to d. Whenever they give horizontal line, use the formula x dy. If they give vertical lines, use y dx formula. This is for horizontal lines. Area under this curve, area bounded by this curve between the lines y is equal to c and y is equal to d. Integrate from y equal to c to y equal to d, x dy. If they give horizontal line means y is equal to constant. Equation of horizontal line is y equal to constant. Equation of vertical line is x equal to constant. All those things you must know properly. Okay. So first few straight lines you learned already. So when they give horizontal lines, use the formula x dy. Okay. And if they give vertical lines, use the formula y dx. Integrate from x equal to a to x equal to b, y dx. In that case, here it is horizontal line. Integrate from y is equal to c to y is equal to dx dy. Hope you understand. Okay. And one more important thing, the curve is lying below the x-axis. In that case, you put modulus for this. When the part of the curve present is below the x-axis, the integration value is going to be negative. But area can't be negative, so make it positive. To make it positive, take the absolute value, modulus function, or put a negative sign like this, as shown here. Integrate from x equal to a to x equal to b along with negative sign, or put modulus function. Whenever part of the curve is present below the x-axis, integration value is going to be negative. That is what I given. F of x is less than 0. Okay. In that case, integration value is going to be negative. In that case, you put modulus function or put a minus sign, so that minus of minus will become plus. Integration value is going to negative for this. Negative of negative becomes positive. Okay. So put modulus function or put a negative sign for that when the part of the curve is present below the x-axis. Remember that. Now I'll take the problems. Question asked in there 1987 and 1994. 2 times same question is asked. Area of the parabola between the lines x equal to a and x equal to 4a. We assume that a is positive here. Y square is equal to 4x. I'll draw here. Y square is equal to 4x. Assuming that a is positive. Y square is equal to 4ax. Between the lines x equal to a and x equal to 4a. So I'll draw x equal to a means it's a vertical line. X equal to 4a is also vertical line, correct? This line is x is equal to 4a. This line is x is equal to a. This line is x equal to a. This line is x equal to 4a. We want to find area bounded by this parabola and these 2 lines. So we want to find this area. Okay. So find the area in the first quadrant and multiply by 2. Both the areas we want. Because of symmetry, find area in the first quadrant and multiply by 2. So required area is, I'll write integral 2 times, integrate from x equal to a to x is equal to 4a. Y dx. Y you find out from the equation of the parabola. Taking the positive square root, y square is 4x. No? From there, you take the positive square root. If you take the positive square root, I get y is equal to 2 root a root x. Correct? So 2 times integrate from x equal to a to x equal to 4a. Y is 2 root a into root x dx. 2 into 2 is 4. 4 root a. Integral of root x is 2 by 3 into x root x. Limits from a to 4a. Correct? Integral of root x is 2 by 3 x root x. Learn the formula so that this 2 is kept out. 2 into 2 is 4 root a is kept outside. Evaluate the function at upper limit and lower limit. 8 root a divided by 3. 8 root a divided by 3. Upper limit you put 4a root a. 4a root of 4a. Evaluate the function at upper limit minus evaluate the function at lower limit. Correct? 2 into 2, 4 root a is kept outside. Integral of root x is 2 by 3 x root x. That is what we get is 8 root a divided by 3. How much you get? Root 4 is 2. 2 into 4 becomes 8. 8a root a I'll get. 8a root a minus a root a. Correct? Evaluate the function at upper limit. Root of 4a. Root of 4a is 2 root a. 2 into 4 is 8. 8a root a minus a root a. That is equal to how much? 8 root a divided by 3. This will be equal to how much? 7a root a. Correct? 7a root a. So 8 into 7 becomes 56. Correct, no? 2 times area in the first quadrant. I want to find. So this will be 8 into 7 is 56a square by 3. 56. Root a into root a is a. A into a becomes a square. A square divided by 3. So answer is none of this. Want to find area in the first quadrant as well as in the fourth quadrant, correct? So find area in the first quadrant and multiply by 2 times area in the first quadrant. A to 4a. Y is 2 root a root x. This 2 is kept outside. 2 into 2 is 4. 4 root a is kept outside. Integral of root x is 2 by 3 x root x. So this becomes 8 root a by 3. Evaluate the function upper limit minus lower limit. Answer is none of this. 56a square by 3 we get. I think here they should have mentioned it is in the first quadrant, area bounded by the parabola and the lines in the first quadrant, okay, because here the answer was none of this, correct? None of this was given. But in this question also it's almost same as this. The same curve is given, y square is equal to 4x between the lines x equal to a and x equal to 4a. Same question asked in the year 2005 also. Y square is equal to 4x and the line x equal to 4a in the first quadrant dimension, okay? In the first quadrant. In the first quadrant if you take, that means you are not multiplying by 2. Find only in the first quadrant. In that case you get 28a square by 3 as answer. There we got 56a square by 3. Here you should get 26a square by 3. If you want to draw again, y square is equal to 4x, like this, correct? Y square is equal to 4x. Want to find area between x equal to a and x equal to 4a. If you want only in the first quadrant, don't multiply by 2, correct? This is x-axis, origin and y-axis. This is x equal to a. This line is x is equal to 4a. Okay, x equal to a, x equal to 4a. Want to find area. Integrate from x equal to a to x equal to 4a, y dx. Y dx. Y is how much from this? 2 root a root x. Correct? A to 4a. Taking the positive square root, I get 2 root a into root x. 2 root a is kept outside. Integral of root x is 2 by 3 x root x. 2 by 3 x root x. Limits from a to 4a. 2 into 2 becomes 4. What you get is 4 root a by 3. 4 root a by 3. 2 into 2 is 4. 4 root a by 3 is constant. Evaluate the function in upper limit. 4a into root of 4a minus a into root of a. That will be how much? 4 root a divided by 3. Correct? Root 4 is 2. 2 into 4 is 8. 8a root a. 8a root a minus a root a. This will be 7a root a, this part. This is 7a root a. Correct? 7 into 4 is 28. A into root a into root a. Root a into root a is a into a square. 28a square divided by 3. So there should be a sentence that it lies in the first quadrant. You want to find the area in the first quadrant or in the fourth quadrant, not both the areas. If you want both the areas, I need to double it. So please make a correction in this. Okay, so drawback of this faulty question. Okay, question asked in the year 2005. Want the next one? So see the difference between this question and the earlier question. Same question. I added a sentence here. Here there is no sentence to be added. So that answer is none of this. We get 56a square by 3. Whereas here I added a sentence that it lies in the first quadrant. So answer is half of that, which is 28a square by 3. Move on to the next one. Area between the curve y equal to 2x minus x square and x-axis. So here coefficient of x square is negative. Y equal to a quadratic function of x means it's a parabola. So where it intersects the x-axis we can find out. When the curve intersects the x-axis, y coordinate is 0. Correct? So I can draw the curve. When the curve intersects x-axis, x-axis implies y equal to 0. Y is equal to 0. Put y is equal to 0 here. I get 2x minus x square equal to 0. 2x minus x square is equal to 0. So x into 2 minus x equal to 0. A into b 0 means either a equal to 0 or b equal to 0. X equal to 0 or x is equal to 2. So coefficient of x square is negative means a downward parabola. Remember, if coefficient of x square is positive means upward parabola. Now it is going to be a downward parabola. Want to find area between this curve and the x-axis. So curve looks like this. Intersects the x-axis at 0 and 2. X equal to 0 and x equal to like this. Something like this. The curve looks like this. This is 2 comma 0 and this is 0 comma 0. Because coefficient of x square is negative, it's opening downwards. This curve is y is equal to 2x minus x square. We need to find this area. So integrate from 0 to 2. I'm using x lines. If you're using x lines, the formula is y dx. Integrate from x equal to 0. Y-axis means x equal to 0. To this line passing through 2 comma 0. If you draw the vertical line passing through 2 comma 0, it's x equal to 2. So integrate from x equal to 0 to x equal to y dx. Required areas. Integral from 0 to 2 y dx. What is y? Y is given to be equal to 2x minus x square. Integrate from 0 to 2. 2x minus x square dx. Integral of 2x is x square. Integral of x square is x cube divided by 3. Limits from 0 to 2. Integral of 2x is x square. Integral of x square is x cube by 3. Evaluate the function in upper limit minus lower limit. Lower limit is anyway 0. Correct? 0 square is 0. 0 cube is 0. So lower limit, both the terms are 0. Upper limit is how much? 2 square 4 minus 2 cube is 8. 8 by 3. Lower limit is 0. I won't write that. 3 is LCM. 3 into 4, 12. 12 minus 8 divided by 3. So answer is 4 by 3. 4 by 3, which we can write it as in terms of mixed fraction. 3 ones are plus 1. 1 1 by 3. 1 1 by 3 square units. Expressed in terms of the mixed fraction. Okay. So the 3 into 1, 3. 3 plus 1 is 4. 4 by 3 is 1 1 by 3. Question asked in the year 1988. Please make a note. Move on to the next one. Area bounded by the curve y equal to 4x minus x square. See, right hand side is a quadratic function, correct? So right hand side is a quadratic in x. So coefficient of x square is negative. So parabola is opening downwards. Where it intersects the x axis, we find out. X axis means y is equal to 0, correct? X axis implies y equal to 0. X axis implies y is equal to 0. Y is equal to 0 substitute. So what do you get? Y is 0 means 4x minus x square should be 0. 4x minus x square is equal to 0. So that you can take x common. X common. So what you get is 4 minus x equal to 0. A into b 0. Either a equal to 0 or b equal to 0. X equal to 0 or x equal to 4. So intersects the x axis 0 and 4. X equal to 0 and x equal to 4. You can draw the curve. Coefficient of x square is negative means right hand side is quadratic in x means y equal to ax square plus bx plus c. It's a parabola. So coefficient of x square is negative. So opening downwards where it intersects the x axis at 0 and 4. So parabola looks like this. Parabola looks like this. Okay. This is 0 and this is x equal to 4, y equal to 0. This point 4 comma 0. So we need to find this area. Integrate from 0 to 4. Y dx, we'll get the answer. Required area is integrate from x equal to 0 to x equal to 4. Y dx. Y dx. Y is what? Y is 4x minus x square. 0 to 4. 4x minus x square dx. Integral of 4x how much? 4 into x square by 2x square minus x cube divided by 3. Limits from 0 to 4. Integral of 4x is 2x square. Integral of x square is x cube by 3. Lower limit is going to be 0, correct? Because 0 square is 0, 0 cube is 0. I won't write the lower limit. I'll evaluate the function only at upper limit. 4 square 16, correct? 2 into 16. Upper limit. X equal to 4. You put 4 cube is 64 divided by 3. So this is 32 minus 64 divided by 3. Take common denominator 3, correct? 32 is 32 by 1. 3 into 32, 96 minus 64. That is equal to 32 divided by 3. 32 divided by 3. Option B is answer. Question asked in the year 1990. Move on to the next one. Area bounded by the curve y equal to x square minus 7x plus 10 and the x-axis. Here you see that right hand side is quadratic in x, therefore it represents a parabola. Coefficient of x square is 1, so it's positive, so it's upward parabola. Where it intersects the x-axis means you put y equal to 0. Where it intersects the x-axis you want to find out. X-axis means y equal to 0. Correct? Y is equal to 0. What is y? Y is given to be equal to x square minus 7x plus 10. So x square minus 7x plus 10 equal to 0. You can factorize this. X minus 2 into x minus 5. X minus 2 into x minus 5 equal to 0. Which gives x is equal to 2, x is equal to 5. Correct? You want to find area. How to draw the curve? If you want to trace the curve for this. It passes through the point where x is equal to 2, y equal to 0 and x equal to 5, y equal to 0. Coefficient of x square is positive, therefore it is upward parabola. It's going to be upward parabola. This area to find out. This area. The part of the curve is present below the x-axis, so modulus function is required. Otherwise, you get negative answer. Area can't be negative, make it positive. So this is 2 comma 0, this is 5 comma 0. This point is 2 comma 0 and this point is 5 comma 0. 2 comma 0, 5 comma 0. Required area is integrate from x equal to 2 to x equal to 5 y dx. What do we get? 2 to 5. Y is what? Y is x square minus 7x plus 10. Integral of x square is x cube divided by 3. Put modulus for this because part of the curve is present below the x-axis. Integration value will be negative, but area can't be negative, so make it positive by putting modulus function. Mod of negative becomes positive, correct? And coefficient of x square is positive, so parabola is opening upwards. Integral of x square is x cube divided by 3. Integral of 7x is 7x square by 2. Integral of 10 is 10x. Limits from 2 to 5. Modulus is there. Put modulus. Evaluate the function. Upper limit minus lower limit. 5 cube is 125 minus 2 cube is 8. 5 cube 125 minus 2 cube is 8 minus 7 by 2 into 5 square 25 minus 2 square 4 plus 10 into 5 minus 2. For this there is modulus. What do you get? This is 117 divided by 3. This is 21. 21 into 7. 147 by 2. 5 minus 2 is 3. 3 into 10 is 30. This is equal to, take LCM, 6. 3 2s are 2 into 117. 234. 2 into 3. Correct? 3 into 147. How much is that? 441 I get. This is 1 into 6, 6 into 30, 180. How much you get? This will be 414. 414 minus 441 minus 27 you get. Correct? 180 plus 234 is going to be 414. 414 minus 441 is minus 27. Mod of minus 27 divided by 6. Mod of negative becomes positive. So 27 by 6, which is 9 by 2. Correct? 3 2s are 3 9s are 9 by 2 is the answer. Option C. Question asked in the year 1992. Hope it's clear. Coefficient of x square is positive, so upward parabola passes intersects the x-axis at x equal to 2 and x equal to 5. X-axis means put y equal to 0. Whenever the part of the curve is present below the x-axis, integration value will be negative. To make it positive, I put modulus function. Mod is put here. Mod of negative becomes positive. Move on to the next one. Area bounded by this curve, you have to find out. X-axis and the curve y equal to 4x minus x square minus 3. Right hand side is quadratic function, correct? So it's a parabola. Y equal to quadratic function means it represents a parabola. And coefficient of x square is negative, so it's a downward parabola, correct? So it's going to be a downward parabola because coefficient of x square is negative. Once again, put x-axis. X-axis implies y equal to 0. X-axis implies y is equal to 0. Y is what? 4x minus x square minus 3. 4x minus x square minus 3 equal to 0. We can multiply by minus 1. We get x square minus 4x plus 3 equal to 0. That is, we can factorize this as x minus 1 into x minus 3 equal to 0, which gives x equal to 1, x equal to 3. So integrate from x equal to 1 to x equal to 3. If you want, you can draw the curve, rough sketch. It passes through the points 1, 0 and 3, 0. Correct? Coefficient of x square is negative. So it is a parabola which is opening downwards like this. If coefficient of x square is positive, opening upwards, now it is opening downwards and it passes through 1, 0, 3, 0 like this. This area I have to find out. Area bounded by this curve, y equal to 4x minus x square minus 3 and the x-axis. This is x equal to 1, 0. This is x equal to 3, y equal to 0. So integrate from 1 to 3. This is 1, 0 and this is 3, 0. So integrate from 1 to 3 y dx. Y is 4x minus x square minus 3. Correct? Integral of 4x is 4x square by 2, which is 2x square. 2x square minus x cube divided by 3 minus 3x. Limits from 1 to 3. Evaluate the function upper limit minus lower limit. What do you get? 2 into 3 square 9 minus 1 square 1 minus 1 by 3 into 3 cube 27 minus 1 cube 1 minus 3 into 3 minus 1. 8 2s are 16, 26, 7 minus 1, 26, 26 divided by 3, correct, 3 minus 1 to 2 into 3, 6, 16 minus 6, 10, 10 minus 26 by 3, which is 4 by 3, correct, 4 by 3 is the answer. Integrate this from x equal to 1 to x equal to 3, integral of 4x is 2x square, integral of x square is x cube, integral of 3 is 3x, upper limit minus lower limit, 3 square minus 1 square. 8 into 2, 16. Correct? 1 by 3 into 3 cube minus 1 cube. 26 by 3 get. 3 into 3 minus 1. 16 minus 6. 10. 10 minus 26 by 3. 30 minus 26 by 3. That is 4 by 3. Question answer in the year 1993. On to the next one. Question number 7 we have. Area bounded by the curve y equal to log x-axis and the line x equal to, already I drawn the curve y equal to log x earlier, correct? So once again I will represent y is equal to log x. Log x will pass through the point 1, 0 because you know that log 1 is 0. Log x means log x base z. This is a curve y equal to log x. Y is equal to log x. Passes through the point 1, 0, correct? Log x always passes through the point 1, 0. And we want to find area bounded by this curve y equal to log x, x-axis and the line x equal to is this, the vertical line, x equal to, we want to find this area, correct? Want to find this area. So integrate from, it passes through 1, 0 means if we draw our vertical line here, that line is going to be x is equal to 1. So integrate from 1 to 2 y dx. Integrate from 1 to 2 y dx. Integration values a is equal to 1 to 2, 1 to 2 y dx, 1 to 2, y is log x equal to 1 to x is equal to 2. Integrate from x equal to 1 to x equal to y dx and y is log x. Integral of log x we know, by integration by parts we learned that integral of log x is x log x minus x, correct? So I won't be doing all the steps, you should remember this because very standard. Integral of log x is x log x minus x. Limits from 1 to 2. Evaluate the function at upper limit minus lower limit. What do we get? 2 log 2, 2 log 2 minus 2. Upper limit. Put x is equal to, wherever there is x you put x equal to. Lower limit x equal to 1. 1 log 1 minus 1. Upper limit is 2. Lower limit is 1. Log 1 is 0. Log 1 is 0. So this becomes 2 log 2. 2 log 2 minus 2. Minus of minus 1 plus 1. Correct? Log 1 is 0. This part is gone. Minus of minus 1 plus 1. Minus 2 plus 1 is going to be minus 1. And 2 log 2 is log 2 square. Oh no, it's there already. Fourth option is answer. 2 log 2 minus 1. Further we can simplify it. 2 log 2 we can write log 2 square. Log 2 square is log 4. Log 4 minus 1 also we can keep. But here itself we got the answer. 2 log 2 minus 1. Question asked here 1995. 2 log 2 could be written as log of 2 square, which is log 4. Correct? 2 log 2 could be written as log of 2 square. Log 2 square, it's log 4 because of the property we have. But anyway, they not use the property of log, they kept as it is. From this, we get the answer. So learn this formula. Please memorize this. Integral of log x is x log x minus x. Of course, we can add a constant c for every indefinite integral. Here, if you add the constant c also, it's going to be cancelled. Upper limit minus lower limit into c is going to get cancelled. So log x curve, very important. Question asked in the year 1995. Move on to the next one. Question number 8 we have. Area bounded by this curve y equal to 4x minus x square. Right answer is quadratic in x. That means y equal to quadratic function is given, means in terms of x, that's going to be a parabola. Coefficient of x square is negative, means a downward parabola. Where it intersects x axis, y equal to 0. X axis implies y equal to 0. X axis implies y equal to 0. Y is equal to 0 means put 4x minus x square is equal to 0. Correct? 4x minus x square is equal to 0. You can take x common. So we get 4 minus x equal to 0, which gives a into b 0, which is a equal to 0, b equal to 0. X equal to 0, x equal to 4. Correct? Because coefficient of x square is negative, it's a downward parabola. Y equal to 4x minus x square. Coefficient of x square is negative, so it's a downward parabola. This is x axis. This area you need to find out. Correct? From x equal to 0 to x equal to 4. So it passes through origin. Sorry, this curve is wrong. I done. Passes through the origin, right? X equal to 0, y equal to 0. This area to find out. X equal to 0 and x equal to 4. This point is 4 comma 0. This area to find out. This curve is y is equal to 4x minus x square. Correct? X equal to 0, y will be 0. Correct? So passes through 0 comma 0 and 4 comma 0. Want to find this area. Because coefficient of x square is negative, it is going to be the downward parabola. Integrate from x equal to 0 to x equal to 4 y dx. This is 0 to 4, y is substitute. What is y? 4x minus x square. Integral of 4x is 4x square by 2, which is 2x square minus x cube divided by 3. Limits from 0 to 4. 2 into 4 square 16 minus 0 minus 1 by 3 into 4 cube 64 minus 0, which is 32 minus 64 divided by 3. Take LCM 3. 32 into 3 is 96. 96 minus 64, which is 32. So required answer is 32 by 3 square units. This is option A. Hope you drawn the other figures properly. Correct? Log x was correct. This is not passing through origin. This is not passing through origin. Correct? Earlier figure, this is passing through origin. 0, 4. Same question, I think. Yeah, 1990 and this question. See, 4x minus x square. Correct? This was 2x minus x square. This is 4x minus x square. Correct? Same question asked here. 4x minus x square. 32 by 3. Okay? Please make a note. Question asked in the 1996. Move on to the next one. Area bounded by this curve y equal to log x base e, x axis, and the straight line x equal to e they ask now. This question is similar to question number 7 here. Correct? Similar to this question. Log x curve. Y equal to log x. X axis. Origin. Y axis. Y is equal to log x. Y is equal to log x base e. And the straight line x equal to e. X equal to e is this line. This is 1 comma 0, right? So it is, this line is x is equal to 1. X is equal to 1 to x equal to this area to find out. Correct? This area. Required area is integral from x equal to 1 to x equal to e. Y dx. Y is log x. Integrate from 1 to e log x dx. Integral of log x is x log x minus x. X log x minus x. Limits from 1 to e. Evaluate the function at upper limit minus lower limit. E log e minus e minus 1 log 1 minus 1. That is E into log E is 1 minus E. Log 1 is 0 minus 1. Correct? Integral of log x is x log x minus x. Very standard. By integration by parts, we learned it. Please memorize it. Okay. And evaluate the function in upper limit minus lower limit. E log E minus 1 log 1 minus 1. Log E is 1. Log E means log E base, which is 1. So E into 1 E. E minus E will be 0. Log 1 is 0. Minus of minus 1 plus 1. Answer is 1 square in it. Question asked in the year 1999. Okay. Move on to the next one. Area of the region bounded by this curve y equal to tan x and the x-axis and the line x equal to pi by 3. The question asked in the year 2022, recent question. Okay, y equal to tan x, I'll draw. Tan x is not defined at every odd multiple of pi by 2, we know. We'll draw the curve in the first quadrant only, y equal to tan x. This is x equal to pi by 2. Okay, I'll draw the vertical asymptote. X is equal to pi by 2. This is, okay. So tan function is increasing function in every quadrant. Even in first quadrant is increasing, okay. So 0 to pi by 2, it goes up like this. Y equal to tan x. Goes up like this. X equal to pi by 3 is here, correct. Pi by 3 is slightly less than pi by 2. So this line is x is equal to pi by 3. Integrate from 0 to pi by 3 y dx. Integrate from 0 to pi by 3. X equal to 0 to x equal to pi by 3. Y dx. X equal to pi by 3 need to find. X axis and the line x equal to pi by 3. X equal to constant is vertical line. X equal to pi by 3 is vertical line. Passes through the point pi by 3 comma 0. Y equal to tan x are represented in the first quadrant 0 to pi by 2. So increasing function. Tan 0 0. Tan pi by 2 is going towards infinity. Correct. So integrate curve y equal to tan x. This curve is y equal to tan x if you want to mention here. Y is equal to tan x, represent it. Integral of tan x from 0 to pi by 3. Integral of tan x is log of mod secant x. Log of mod secant x. Limits from 0 to pi by 3. Evaluate the function at upper limit minus lower limit. Log of secant pi by 3 minus log of mod secant 0. Correct? Secant pi by 3 is 2. Secant pi by 3 is 2 and secant 0 is 1. Log 1 is 0. So I get log 2 minus 0 which is equal to log 2. Log 2 square inverse. Integral of tan x is log of mod secant x. Evaluate the function at upper limit minus evaluate the function at lower limit. Secant pi by 3 is 2, secant 0 is 1, log 1 is 0. So log 2 minus 0, log 2. Question asked in the year 2022. Move on to the next one. Question number 11 we have area of the region bounded by this curve y equal to root of 16 minus x square. Root of 16 minus x square represents a semicircle. Y equal to root of a square minus x square represents semicircle. So that lies in the first and second column like this. Y equal to root of 16 minus x square. Root of 16 minus x square is a semicircle. So upper part of the circle lying in the first and second quadrant. Area of this is going to be, we want to find area bounded by this and x-axis. So we want to find area both in the first quadrant as well as in the second quadrant. Required area is half of the area of the circle. Half of area of the circle. Area of the circle is how much? Pi r square. If you square this and simplify, rewrite this, I'm going to get the equation of circle. So if you square this, I'm going to get y square is equal to 16 minus x square. And if you rearrange the terms, I get x square plus y square is equal to 16, which is the equation of circle having radius as 4, correct? So area of this circle is going to be pi r square. R square is 16, so 16 pi is the area. So half into 16 pi. Half into 16 pi, which is equal to 8 pi. 8 pi square units. Half of the area of the circle. Area of circle is pi r square. X square plus y square equal to r square. R square is 16. 16 pi is area of the circle. Area of the semicircle is half into area of the circle. Half into 16 pi is 8 pi square units. Question asked in the year 2021. Move on to the next one. Area of the region bounded by this line y equal to mx between x equal to 1 and x equal to x axis given to be equal to 6. Want to find the value of m. So y equal to mx. We assume that m is positive here. Correct? All the options are positive. So I'll take y equal to mx as m positive, so that we know that line is passing through the origin like this, and it lies in the first and third quadrant. Y is equal to mx lies in the first and third quadrant if m is positive. Area is already given to us, bounded by the lines x equal to 1 and x equal to 1, x equal to other vertical lines. X equal to constant is vertical line, remember. X equal to 1, x equal to 2. This area is given between x equal to 1 and x equal to and x axis. This area is given as how much? 6. So want to find integral from 1 to 6. X equal to 1 to x equal to 2 y dx. What is area? Area is 6. Integral from 1 to 2, y is mx. M into integral of x is x square divided by 2. Limits from 1 to 2. Correct? This 2 you can cross multiply. Area is already given to be equal to 6. Want to find the value of m. Integrate from 1 to 2, because from the lines, between the lines x equal to 1 and x equal to of the line y equal to mx and x axis given to be equal to 6 area. 6 into 2 is 12. 12 is equal to m into, evaluate the function in upper limit, 2 square minus 1 square. 2 square is 4, 4 minus 1, 3. 3m is equal to 12, implies m is equal to 4. M is equal to 4. Option D is the answer. Question asked in there, 2014. 2 square is 4, 4 minus 1, 3. 3m is equal to 12, so m is equal to 4. Is it clear? Area was given to be equal to 6. M is constant, keep outside. Integral of x is x square by 2. Cross multiply. 2 into 6, 12. 12 is equal to m into 2 square minus 1 square. 4 minus 1, 3. 3m is equal to 12. M is equal to 4. Move on to the next one. Question number 13. We have area bounded by the curve y equal to x cube, y equal to 8 and x equal to 0. X equal to 0 is the equation of y axis. We know how to draw the curve y equal to x cube. Y equal to x cube is like this. Y equal to x cube. Y equal to x cube. Extends indefinitely downwards, indefinitely upwards. Y equal to x cube. Correct? Y equal to x cube. Y equal to 8 is horizontal line. Y is equal to 8 is horizontal line. X equal to 0 is the equation of y axis. That means this area you have to find out. Area bounded by y equal to x cube. Y equal to 8 is horizontal line. Y equal to constant is horizontal line. X equal to 0 is the equation of y axis. So given the horizontal lines, y lines are given, the formula will be x dy. So required area is integral from y is equal to 0 to y is equal to 8. Because the given y lines, my formula will be x dy. With respect to y axis I am doing. Y is equal to 0 to y is equal to 8, x dy. X how much? Because y is x cube, x will be equal to y power 1 by 3. Correct? Substitute. X is y power 1 by 3. Y power 1 by 3. Integral of y power 1 by 3 is how much? Y power 1 by 3 plus 1 by 1 by 3 plus 1. 1 by 3 plus 1 is 4 by 3. Y power 4 by 3 divided by 4 by 3. Limits from 0 to 8. 1 by 4 by 3 is 3 by 4. 1 by 4 by 3 is 3 by 4. Evaluate the function at upper limit. 8 power 4 by 3 minus 0 power 4 by 3. This is 3 by 4 into 0 power 4 by 3 is 0 there. 8 you can write 2 cube to the power 4 by 3. Evaluate the function at upper limit minus lower limit. You get 3 by 4 into, this will be powers gets multiplied, 3 cancels, 2 power 4 is 16, 4 1s are 4 4s are, 4 into 3 is 12. So required answer is 12 square units. Question asked in the year 2015. Here important thing is the given y lines. So integrate with respect to y. The formula is x dy. Y is x cube. From there you get the value of x. X is y power 1 by 3. Okay. Substitute and integrate using integral of x power n formula. X power n plus 1 by n plus 1. Evaluate the function upper limit minus lower limit. Get the answer. Move on to the next one. Question number 14 we have on this area bounded by simple curves I'm doing. Y equal to x square and y equal to 16. Two times the same question is asked. 2017 and 2025. Y equal to x square, we know how to represent y equal to x square. It's a parabola having axis along y axis. Y equal to x square. Same as x square is equal to y. Correct? And horizontal line. Y equal to 16 is horizontal line. Y equal to x square and y equal to 16. Y equal to x square. This is y is equal to 16. Want to find area between the curve and the line y equal to 16. This area to find out, as well as this area. Find area in the first quadrant and multiply by 2. Required area is 2 times integral from where to where. Using the y lines. Again the formula is x dy because I am using y lines. X axis means y equal to 0. I am finding area in the first quadrant and multiply by 2. Correct? 2 times area in the first quadrant. To find area in the first quadrant, integrate from y is equal to 0 to y is equal to 16. X dy. X dy. X how much? From y equal to x square, taking the positive square root, x is root y. Correct? So 2 times integrate from 0 to 16, x is root y. Integral of root y is 2 by 3 y power 3 by 2. 2 by 3 y root y, right? Evaluate the function at upper limit minus lower limit. What do we get? 4 by 3 into upper limit is 16. 16 root 16 minus 0 root 0. 4 by 3 into this part is 0. Root 16 is 4. 4 into 16 is 64. 64 into 4. Answer is 256 divided by 3. 256 divided by 3. 2 times same question is asked. Learn how to draw the curve y equal to x square. It's a parabola having vertex at origin symmetric with respect to y axis. Quadratic in x means symmetric with respect to y axis. Quadratic in x means it is symmetric with respect to x axis. Quadratic in y means symmetric with respect to x axis. Here it is quadratic in x, so symmetric with respect to y axis. And y equal to 16 is horizontal line. Y equal to constant is horizontal line. So integrate from 0 to 16. Because the given y lines, I am integrating with respect to y using the formula x dy. X is root y because y equal to x square. From there, taking the positive square root, I get x equal to root y. Finding area in the first quadrant and multiplying by 2, we get this. Answer is 256 divided by 3. Question asked 2 times in the year 2017 and 2025. Move on to the next one. Question number 15 we have. Area bounded by the line y equal to x axis and the ordinates x equal to minus 1 and x equal to, y equal to x is a straight line passing through the origin, bisects the first and third quadrant. Correct? Y equal to x. Y equal to x is the straight line passing through the origin, which bisects the first and the third quadrant. We want to find area between the lines x equal to minus 1 and x equal to 2. X equal to minus 1 and x equal to both are vertical lines because x equal to constant is vertical line. This is x equal to minus 1 and this is x equal to 2. This is x equal to 2 and this is x equal to minus 1. Want to find this area. You can either use integration method or else you can use area of triangle method. Any method will give the answer. Okay, I will do both the methods for you. Integrate from minus 1 to 0 and 0 to 2. Required area is integral from minus 1 to 0 y dx. Y is x dx. Here I should put modulus function because part of the curve is present below the x axis. Integration value will be negative. Area can't be negative. So to make it positive, put modulus function. And 0 to 1, 0 to 2, correct? 0 to 2, y dx. Y is x. Here modulus is not required. Integral of x is x square divided by 2. X square divided by 2. Limits from minus 1 to 0. Modulus is there. Integral of x is x square divided by 2. Limits from 0 to 2. Is equal to how much? 1 by 2 into 0 square is 0. Minus 1 square is 1. Modulus is there. Here half into 2 square 4 minus 0. Correct? Mod of minus half becomes plus half. Plus 4 by 2. 4 by 2 plus 1 by 2 is going to be 5 by 2. If you don't put modulus, you will get wrong answer. See, if you don't put modulus, minus 1 by 2 plus 4 by 2, 3 by 2. 3 by 2 is wrong. 5 by 2 is the answer. Okay? Option B. If you want, you can do it by area of triangle method also. So, you find area of this triangle as half into base into height, general formula. Also find area of this triangle and add up those two. So, this is the base, no? So, this point is 2, 0 here. X equal to means this point on the x-axis is 2, 0. And when x is 2, y is 2. This point is 2, 2 here. 2, 2. So, area of this triangle is, this length is 2. 0, 0, 2, 0. Distance between those 2 points is 2. 2, 0, 2, 2. Distance between those 2 points is 2. Correct? If x coordinate is same, subtract the y coordinates. If y coordinate is same, subtract the x coordinate. Put modulus, of course. So, area of this triangle is half into base into height. Half into base is 2, height is 2. Correct? Base is 2. Distance between 0, 0 and 2, 0 is 2. Distance between 2, 0 and 2, 2 also 2. This is 2, this is 2. Half into base into height. Here, this is 0, 0. This is minus 1, 0. This is minus 1, 0. So, this length is 1. Correct? Base is 1. Height how much? When x is minus 1, y is also minus 1 because it is y equal to x. So, this point will be minus 1, minus 1. Correct? So, this length how much? Minus 1, 0, minus 1, minus 1. X coordinate is same. Subtract the y coordinates. 0 minus 1 becomes plus 1. So, this is length is 1. This length is 1. So, area of that triangle is half into base into height. Base is 1, height is 1. This is 4 by 2, this is 1 by 2. 4 by 2 plus 1 by 2, 5 by 2. Same answer we get. Either by integration we can do or by using area of triangle method we can get the answer, whichever easy. But remember, whenever the part of the curve is present below the x-axis, integration value is going to be negative. To make it positive, we put modulus function because area can't be negative, so put modulus function. Question asked in the year 2018. Move on to the next one. Yeah. Question number 15 here. Area bounded by the curve x equal to 4 minus y square and the y-axis. X equal to 4 minus y square. Y-axis means this is quadratic in y, correct? So, the parabola, it's a parabola only, but it is, you want to find with respect to y-axis. When it intersects the y-axis, x equal to 0, correct? Y-axis implies x equal to 0. When the curve is going to intersect the y-axis, x is equal to 0. X how much? X is 4 minus y square. So, 4 minus y square equal to 0. 4 minus y square is equal to 0. So, y square is equal to 4. Y square is equal to 4 means y is equal to plus or minus 2. So, the curve will be passing through the point 0, 2 and 0, minus 2. Something like this. 0, 2 and where it intersects the x-axis. X-axis means y equal to 0, correct? If it intersects the x-axis, at that point, y equal to 0. Y equal to 0 we put here. X will be 4, correct? X will be 4 minus y square, that is 4 minus 0, which is equal to 4. So, the parabola will be passing through the point 4, 0 here. This is 4, 0 and also it passes through the point 0, 2 and 0, minus 2. 0, 2 is here on the positive y-axis. This is 0, minus 2. So, parabola looks like this. Parabola looks like this. Want to find this area with respect to y-axis, correct? The curve is given like this. X equal to 4 minus y square. X equal to 4 minus y square. And the y-axis. So, find area in the first quadrant and multiply by 2. So, required area is 2 times integrate from where to where? Integrate from x-axis y equal to 0 to y is equal to 2. Integrate from y is equal to 0 to y is equal to 2 x dy. Because I am using the y lines, x-axis means y equal to 0. This is y equal to 2, correct? If you draw one horizontal line here, it's y is equal to 0 to 2 x dy. That is 2 times 0 to 2 x, how much? X is 4 minus y square. 4 minus y square dy. 2 times integral of 4 is 4y. Integral of y square is y cube divided by 3. Limits from 0 to 2. Correct? Evaluate the function in upper limit minus lower limit and get the answer. This will be 2 times. Lower limit is anyway 0. 4 into 0, 0. 0 cube is 0. I won't write the lower limit. Upper limit is 2. 4 2s are 8. Correct? 2 cube is 8. 8 by 3. So 2 into, I'll get 8 minus 8 by 3. Take LCM. 8 3 is 24. 24 minus 8 is 16. So I'll get 32 by 3 as answer. 32 divided by 3. Correct? Answer is 32 by 3. Option D. Question asked in the year 2007. Learn how to draw the curve first. Find area in the first quadrant and multiply by 2. Want to find area bounded by this curve and the y-axis. Question asked in the year 2007. On to the next one. Question number 17. We have area of the region bounded by this y equal to 2x minus x square and x-axis. 2008, in the year 2008 the question was asked. So when the curve intersects x-axis, y equal to 0. X-axis implies y equal to 0. Y is equal to 0. Y is how much? Y is 2x minus x square. 2x minus x square equal to 0. That means x into 2 minus x equal to 0. That means x is equal to 0, x is equal to 2. Correct? Integrate from 0 to 2. You can draw the curve. Right hand side is quadratic in x. That means y equal to ax square plus bx plus c form. So a parabola. Coefficient of x square is negative. So it's a downward parabola. Passes through 0, 0 and 2, 0. Correct? The parabola is passing through 0, 0 and 2, 0. Something like this. Opening downwards because coefficient of x square is negative. The curve is y equal to 2x minus x square. Y is equal to 2x minus x square. Integrate from 0 to 2. This point is 2, 0. Required area is integral from x equal to 0 to x is equal to 2 y dx. 0 to 2. Y is 2x minus x square. Correct? Integral of 2x is x square. Integral of x square is x cube divided by 3. Limits from 0 to 2. Lower limit is 0. 0 square 0. 0 cube 0. So I won't write the lower limit. Only upper limit. 2 square is 4. 2 cube is 8. 4 minus 8 by 3. Take LCM 3. 3 into 4. 12 minus 8, which is 4 by 3. 4 by 3 square root is option B. Question asked in the year 2008. Coefficient of x square is negative, so downward parabola. Passes through 0, 0 and 2, 0. Okay. Move on to the next one. Question asked in the year 2010. Area bounded by the curve y equal to x square for x less than 0, y equal to x for x greater than or equal to 0, and the line y equal to 4. Once again, they give an horizontal line. Y equal to constant is horizontal line. Remember this. So, need to draw this curve. For x less than 0, it's y equal to x square. Y equal to x square for x less than 0. This is y-axis, origin, x-axis. For x less than 0, it's y equal to x square. Y equal to x square like this. And for x greater than or equal to 0, it is y equal to x. This is y equal to x. For x greater than or equal to 0. And y is equal to x square for x less than 0. This is y equal to x square for x less than 0. Less than 0 means left side of 0. Greater than or equal to 0 is right side of 0. Correct? So you want to find area bounded by this and the line y equal to 4. Y equal to 4 is the horizontal line. Y equal to 4. This area I have to find out. Correct? Integrate from y is equal to 0 to y is equal to 4x dy. Required area is integral from y is equal to 0 to y is equal to 4. correct? X dy, x is from the line, x dy, x is from the line, and also integrate from y equal to 0 to y is equal to 4, x dy, x is from the parabola. This is from the parabola. Y is x is what? From the line y is x, so x will be y. Integrate from 0 to 4, 0 to 4, x is y dy, plus integrate from 0 to 4, what is x? X is root y is x square. From there we take the positive square root, we get x is root y. Integral of y is going to be y square divided by 2, limits from 0 to 4. And integral of root y is going to be 2 by 3 y root y, limits from 0 to 4. Evaluate the function at upper limit minus lower limit. 4 square, 16 minus 0, 16 minus 0 divided by 2, correct? 2 by 3 into upper limit here, 4 root 4 minus 0. This is 16 by 2, which is 8. Here root 4 is 2, 2 into 4, 8, 8 2 is 16, 16 by 3 plus 8, take LCM 3, 8 3 is 24 plus 16, answer is 40 by 3. Forty by 3 is answer, option A. Question asked in there, CET 2010. On the next one. Area bounded of the region y equal to x plus 1 and the lines x equal to 3 and x equal to 5. Draw the line y equal to x plus 1. Y equal to x plus 1. Y equal to x plus 1 is a straight line, correct? To draw the straight line, we require minimum 2 points. Y equal to x plus 1, I'll represent. Take x equal to 0, y will be equal to 1. Correct? When x is 0, y is 1. When y is 0, x will be minus 1. So it passes through 0, 1 and minus 1, 0. Minus 1, 0 is here. 0, 1 is here. This is 0, 1 and this is minus 1, 0. Want to find the area bounded by this line y equal to x plus 1 and the lines x equal to 3 and x equal to 5. Extend this. X equal to 3 is a vertical line. X equal to 5 is also a vertical line. X equal to 3, the x equal to 5, this is y equal to x plus 1. This line is y equal to x plus 1, passes through 0, 1 and minus 1, 0. Correct? Between the lines x equal to 3 and x equal to 5 and the x-axis they should have mentioned actually. Correct? And the x-axis. Not mentioned the word and x-axis. So that area gets bounded, correct? So we need to find integral from x equal to 3 to x equal to 5 y dx. X equal to 3 to x equal to 5 y dx. 3 to 5, y is what? X plus 1. Integrate this. Integral of x square divided by 2. Integral of 1 is x. Limits from 3 to 5. Evaluate the function at upper limit minus lower limit. Half into 5 square 25, 3 square 9. Here 5 minus 3. This is 16 by 2, 8. 5 minus 3, 2, 8 plus 2, 10. 10 square units. Hope it's clear. Just integrate the line y equal to x plus 1 from x equal to 3 to x equal to 5. This should mention the word and x-axis. Question asked in the year 2023. To draw the straight line, we take minimum 2 points. When x is 0, y is 1. When y is 0, x is minus 1. So 0, 1 and minus 1, 0. Passing through those 2 points. Draw the line and integrate it. Get the answer. On to the next one. Area of the region bounded by this line y equal to 2x plus 1 x-axis and the ordinates x equal to minus 1 and x equal to 1. Y equal to 2x plus 1. To draw the straight line, y is equal to 2x plus 1. I'll take 2 points. When x is 0, y is 1. When y is 0, x is minus half. So using these 2 points, I can represent the straight line y equal to 2x plus 1. X-axis and the ordinates x equal to minus 1 and x equal to 1. X equal to minus 1 is here, x equal to 1 is here. It passes through the points 0, 1 and minus half, 0. 0, 1 is here. Correct? When x is 0, y is 1. When x is minus half, y is 0. This is minus half, 0. The line is passing through these 2 points. Like this. Minus half, 0. And we need to find area between the ordinates x equal to minus 1 and x equal to 1. X equal to minus 1 is here. This is x equal to minus 1. Here x is equal to 1. So if you are doing by integration method, integrate from minus 1 to minus half the line plus minus half to 1 the line. And when the part of the curve is present below the x-axis, you need to put modulus function. Correct? So that integration value is going to be negative. Mod of negative becomes positive. I'll do both the methods. One is by integration method, another by area of triangle method. If you are doing by integration method, we can integrate from minus 1 to minus half. Minus 1 to minus half y dx. What is my y? Y is 2x plus 1. 2x plus 1 dx. Correct? Put modulus for this. And next one, minus half to 1. Minus half to 1. There it is, the curve is present above the x-axis. No need to put modulus function. Directly we can get the answer. Of course, it will be positive. Here integral of 2x is x square. Integral of 1 is x. Limits from minus 1 to minus half. Integral of 2x is x square. Integral of 1 is x. Minus half to 1. Upper limit minus lower limit. Minus half square is going to be 1 by 4. Minus 1 square is 1. Upper limit minus lower limit. Minus half square 1 by 4 minus 1 square is 1 plus, correct, no, minus half minus 1 minus half plus 1, that is half, mod of this, plus here 1 square 1 minus half square is 1 by 4, here 1 minus half 1 plus half, correct. So this is 1 by 4 minus 1 minus 3 by 4. Minus 3 by 4 plus half is minus 1 by 4, correct? So mod of minus 1 by 4 will be 1 by 4 there. 1 by 4 minus 1 is minus 3 by 4. Minus 3 by 4 plus half is minus 1 by 4. Mod of minus 1 by 4 is 1 by 4. 1 minus 1 by 4 is 3 by 4. 1 plus half is 3 by 2. Correct? 1 by 4 plus 3 by 4. This sum is going to be 1. 1 plus 3 by 2 becomes 5 by 2. 5 by 2 is answer. Option C. If you want, you can do it by area of triangle method. Half into base into height. Required area is half into area of this triangle. This triangle will find out. This length is 3 by 2. Correct? This is 1. This is half. 1 plus half, 3 by 2. Base is 3 by 2. Height how much? This line is y is equal to 2x plus 1, right? So if you want to find out this point, this is a vertical line. Vertical line means x coordinate will be same. All the points on that line will have x equal to 1. So this point will be x equal to 1, y will be 3. So if you want to find this height, this is 1 comma 0, 1 comma 0. This point is 1 comma 0. This point is 1 comma 3. This height is 3. The x coordinate is same. Subtract the y coordinate. 1 comma 3, 1 comma 0. Subtract the y coordinate because x coordinate is same. 3 minus 0 is 3. This triangle area is over. This triangle area you want. Half into base into height. Half into base how much? This length is half, correct? Minus half, minus 1. Minus half plus 1, half it is. And if you want to find out the height, no, this point is minus 1 comma 0. Here all the points will have x equal to minus 1 because it's a vertical line. So this point will be when x is minus 1, y is how much? 2 into minus 1 is minus 2. Minus 2 plus 1 becomes minus 1. Put x equal to minus 1 in the equation y equal to x plus 1. Minus 2 plus 1 is minus 1. So this is minus 1 comma 0, minus 1 comma minus 1. Distance between these two is going to be 1. Correct? So this becomes 3 into 3, 9, 2 into 2, 4, 9 by 4 plus 1 by 2. Correct? Which is equal to how much? So 1 by 4. 9 by 4 plus 1 by 4 here. 1 by 2 into 1 by 2, 1 by 4. So this will be 10 by 4. 10 by 4, which is equal to 5 by 2. Same answer you get. See, 5 by 2, 5 by 2. Either you can do by integration method or by area of triangle. Area of this triangle plus area of this triangle. But point to be noted, when the part of the curve is present below the x-axis, integration value will be negative. To make it positive, put modulus function. Otherwise, it will go wrong. Question asked in the year 2020. On to the next one. Here we have some note. Area bounded by sin x and cos x between x equal to 0 and 2 pi given. Y equal to cos x from 0 to 2 pi. Remember, it's going to be 4 square units. Y equal to sin x from 0 to 2 pi is going to be 4 square units. And for cos x and sin x, for both of them, 0 to pi, area bounded is 2 square units. Okay, between the curve and the x-axis. Y equal to sin x, if we take between x equal to 0 and x equal to pi by, it's going to be 2 by a. It's quite important, all these things. The same works for cos x also. Cos x between x equal to 0 to x equal to pi by a is 2 by a square units. Okay. So this is the most important thing, and it is referred to as one arch of the curve y equal to sin x, sine function. Y equal to sin x between the coordinates x equal to 0 and x equal to pi by and x-axis. One you can take and x-axis. Okay. And x-axis is referred to as one arch of the curve sine function. And x-axis, you can add one sentence here. And x-axis. And x-axis. So this is 0 to pi is called as one arch for this. If it is 0 to pi by a sin ax, for that it's one arch. Now it is sin x, so 0 to pi area is going to be 2 square units. This area also going to be 2 square units. 2 plus 2 is 4. If you want 0 to 2 pi for sin x, area bounded is 4 square units. This much is 2, this much is 2. 2 plus 2, 4. Okay. So 0 to pi is called as one arch of the function y equal to sin x. And if you take y equal to sin ax, y equal to sin ax, if you take from 0 to pi by a, it's going to be 2 by a. Remember this. For y is equal to sin ax, if you take from x equal to 0 to x equal to pi by a, and the x-axis. Okay. This is going to be 2 square units, 2 by a square units. If it is sin x, 0 to pi, 2 square units. If it is sin ax, from 0 to x equal to 0 to x equal to pi by a and x-axis, area bounded is going to be 2 by a square units. Area is going to be 2 by a square units. Most important thing. Okay. Already this year also one question was asked. So directly we can answer these questions. And this is y equal to cos x between 0 to 2 pi. Here also we get 4 square units. 0 to pi for cos x is 2 square units. 0 to 2 pi area bounded by y equal to cos x and x-axis is going to be 4 square units. Okay. So all these things you should know. And directly we can answer these questions. Y equal to sin x, x-axis from x equal to 0 to x equal to 2 pi is going to be 4 square units. Directly you can answer. If you want, I can show the steps. 0 to pi and pi to 2 pi. Area bounded is integral from x equal to 0 to x equal to pi. Y is equal to sin x. Correct? 0 to pi sin x. And pi to 2 pi again sin x. Pi to 2 pi means the part of the curve is present below the x-axis. So integration value will be negative. So to make it positive, put modulus function. Integral of sin is minus cos x. Correct? Limits from 0 to pi. Integral of sin x is minus cos x. Integral of sin x is minus cos x. Limits from pi to 2 pi. Put modulus. This is minus of cos pi minus 1 minus cos 0 1. Mod of minus of cos 2 pi. Cos 2 pi is 1 minus cos pi is minus 1. Correct? Cos pi minus 1, cos 0 1, cos 2 pi 1, cos pi is minus 1. Minus of minus 1, minus 1 minus 1, minus 2. Minus of minus 2 becomes plus 2. Here also 1 plus 1, 2. Mod of minus 2 plus 2. 2 plus 2 is 4. 4 square meters. I want to be working out all these things because it's very standard. 0 to pi, again, sin x. 0 to pi sin x is 2 square meters. Remember, 0 to pi forms one arch of the curve y equal to sine function. 0 to pi, remember, 2 square meters. 0 to 2 pi is going to be 4 square meters for both sine function as well as cos function. It's very standard result. No need to work out. Directly we can answer. And area enclosed between the x-axis and one arch of the curve y equal to sin x. One arch means 0 to pi. 0 to pi area bounded is 2 square meters. Question asked there, 1991. Straightforward, we can answer. Next one we have area bounded by the curve y equal to sin x between x equal to 0 and x equal to 2 pi is going to be 4 square meters. Directly we can answer. Question asked there, 1997. Straightforward question. Okay. Next one we have area of the region bounded by y equal to cos x from 0 to pi, and x-axis word should have been mentioned here, and x-axis, okay, 0 to pi is going to be 2 square meters. Question asked in 2017 and 2008, 2 times same question is asked. If you want, you can work out 0 to pi by 2 cos x plus pi by 2 pi cos x, correct? Cos x curve we know already drawn, correct? It's shown the function, cos function graph here. 0 to pi by 2 plus pi by 2 to pi by 2 to pi is 0. This is pi by 2 to pi. 0 to pi by 2 is above the x-axis. Integral from 0 to pi by 2 cos x dx. And pi by 2 to pi, it is present below the x-axis. Below the x-axis means you should put modulus function. Correct? Integral of cos x is sin x. Limits from 0 to pi by 2. Integral of cos x is sin x. Limits from pi by 2 to pi. When the part of the curve is present below the x-axis, put a modulus function. Put modulus function. This is sin pi by 2 minus sin 0. Here, sin pi minus sin pi by 2. Correct? Sin pi 0. Sin pi by 2 is 1. Correct? 1 plus 0 minus 1 minus 1. Mod of minus 1 is 1. 1 plus 1 is 2. 2 square units. Move on to the next one. All these things were done. Cos x is 2 square units. And one more question. This is asked 2 times recently, 2025 as well as 2013. Y equal to sin x by 3 x-axis between 0 to 3 pi. Answer is 6. Directly we can answer. We know that y equal to sin x. Y is equal to sin x. If it is given from x equal to 0 to x equal to pi by a, and x-axis is going to be, and x-axis is going to be 2 by a square units. Correct? Area is 2 by a square units. Here sin x by 3 is given. Instead of sin x, what is given? Sin x by 3. Sin x by 3 between where x equal to 0 to x is equal to 3 pi. 0 to 3 pi. If we compare sin x by 3. So a is 1 by 3, correct? Here also you can compare. Put a equal to 1 by 3. Pi by 1 by 3 gives 3 pi. So area is how much? 2 by a. A is 1 by 3. 2 by 1 by 3. That is 2 into 3, which is equal to 6. Answer is 6 square roots. Option C. Directly we can answer. 2 by a, where a is 1 by 3. Over. Within 10 seconds, we can crack this question. If you are doing the actual method, I can do it. Integrate from 0 to 3 pi. Y equal to sin x by 3. Just integrate from 0 to 3 pi, I will get the answer. Integrate from 0 to 3 pi. Y is sin x by 3. Integral of sin is minus cos. Is equal to minus cos x by 3 divided by coefficient of x. Coefficient of x is 1 by 3. Limits from 0 to 3 pi. This is alternate method or second method I can call. This is 1 by 3 is 3 minus 3 into. Evaluate the function at upper limit. Cos of 3 pi by 3 pi minus cos of 0 by 3 0 is equal to minus 3 into cos pi is minus 1, cos 0 is 1, minus 1 minus 1 minus 2 into minus 3 plus 6. Same answer we get. Any method you can do. 2 times, same question asked. Please make a note. Move on to the next one. Area of the circle and ellipse we have. Area of circle we know pi a square. Area of ellipse is pi ab. Correct? Area of the circle are given x square plus y square equal to a square. Or it can be in the shifted form also. Even if it is x minus h the whole square plus y minus k the whole square equal to a square. Then also area is going to be pi a square only. Even for the circle of this type. X minus h the whole square plus y minus k the whole square is equal to a square. Area is going to be pi a square. That doesn't change. Area of ellipse x square by a square plus y square by b square equal to 1 is pi ab. Whether the major axis is along x axis or along the y axis, any type of ellipse, the area is going to be same, pi ab only. And the parametric equations are given for circle x square plus y square equal to a square, x equal to a cos theta, y equal to a sin theta. Parametric equations for circle x equal to a cos theta and y equal to a sin theta for the circle. And for ellipse, no, it is x square by a square plus y square by b square equal to 1. The parametric equations are x equal to a cos theta, y equal to b sin theta. Because sometimes we'll ask to find area bounded by the curve whose parametric equations are given. Okay, in that case, using the parametric equations, you can find the area. So if they give, find the area bounded by the curve whose parametric equations are x equal to 3 cos theta, y equal to 5 sin theta. It represents ellipse. A cos theta, b sin theta represents the equation of ellipse. So area of ellipse you can find pi ab. 3 into 5, 15 pi is the answer in that case. If the parametric equation, one such question is found in the NCERT exemplar book. So I am telling you. Okay, learn area of circle and area of ellipse and also their parametric equations. The theta is called parameter. Move on to the next one. Problems on this. Area of the ellipse you have to find x square by 9 plus y square by 4 equal to 1. We know, compare this x square by a square plus y square by b square equal to 1. A square is 9. Comparing, we get a square is equal to 9, b square is equal to 4. Correct? Compare the equation with x square by a square plus y square by b square equal to 1. A square is 9, b square is 4. Taking the positive square root, a is equal to 3. I get a is equal to 3, b square is 4. Taking the positive square root, b is equal to 2. Area of ellipse is pi ab. Area of ellipse is pi ab. Pi into 3 into 2. So answer is 6 pi square units. Option B. So simple question. Okay. Just remember the standard result. Area of ellipse is given by pi AB. A is 3, B is 2. 3 into 2, 6. 6 pi is the answer. Question asked in the year 1984. Move on to the next one. Area of the ellipse is very standard. X square by a square plus y square by b square equal to 1. Area of ellipse is pi AB. Question asked in the year 1993. If they ask area of ellipse only in the first quadrant, then it becomes pi AB by 4. If they mention only in the first quadrant, you want to find area. Now it's not asked. So answer is pi AB. Sometimes they'll ask even such kind of questions. Area of the ellipse x square by 9 plus y square by 4 equal to 1. This is same as this question. No? Same question is asked. X square by 9 plus y square by 4 equal to 1. Answer is 6 pi. Correct? 6 pi is the answer. A is 3, B is 2. Pi AB. 3 into 2. 6 into pi. 6 pi. Next one. Area of the ellipse is given to be 20 pi. Find the value of lambda. So here x square by a square plus y square by b square equal to 1. If you compare, a square is 25. A square is 25 and b square is lambda square. Compare the equation of ellipse with x square by a square plus y square by b square equal to 1. So a square is 25. If a square is 25, I can give that a is equal to 5. B square is lambda square, means b is equal to mod lambda. B is equal to mod lambda. Lambda can be positive or negative, but b is always positive. So b is mod lambda. We don't know, lambda can be positive or negative, but b should be positive. So b is mod lambda. Correct? Area of ellipse is given, pi AB. Area of ellipse given to be equal to 20 pi in the question. Want to find lambda. Area of ellipse is given to be equal to 20 pi. This is given in the question. Area of ellipse is 20 pi. Area of ellipse is pi AB. pi AB is equal to 20 pi. Pi cancels. AB is equal to 20. A is how much? A is 5. B is mod lambda. Correct? 5 ones are 5 fours are cancels. So what you get is mod lambda is equal to 4. Mod lambda 4 means lambda is equal to plus or minus 4. Correct? Because mod of 4 is 4. Mod of minus 4 also 4. Both the values satisfies. Mod lambda is 4 implies lambda is plus or minus 4. Question asked in the year 2021. Move on to the next one. Area of the region bounded by this curve. This is also the equation of ellipse only. We can rewrite this as 9x square plus 4y square equal to 36. 9x square plus 4y square equal to 36. Divide throughout by 36. Divide throughout by 36. Divide throughout by 36. When you divide by 36, what do you get? X square divided by 4 plus y square divided by 9 is equal to 1. Divide by 36. 36 by 36, 1. 9 ones are 9 fours are. 4 ones are 4 nines are. So you can compare this equation with x square by b square plus y square by a square equal to 1. Correct? Compare with x square divided by b square. This is coefficient of y square in the denominator is bigger. So x square by b square plus y square by a square is equal to 1. If we compare, b square is 4, so b is equal to 2. A square is equal to 9, so a is equal to 3. Area is pi AB. Area of ellipse is going to be equal to pi AB. Pi into a is 3 here, b is 2. Correct? Answer is 6 pi itself. 6 pi square root. Question answer there 2005. B is 2 and A is 3. Compare x square by b square plus y square by a square equal to 1. While comparing, always see that coefficient of A value should be bigger and coefficient of y square in the denominator is bigger. This is the vertical ellipse. So vertical ellipse. Major axis will be along the y axis. But still area is same. Area doesn't change. Okay, so b is 2, a is 3, so 3 into 2, 6 into pi, 6 pi square meters, area of ellipse. So questions can be asked on area of ellipse, already asked many times. Next we have area bounded by the parabola and its lattice rectum. No questions are asked on this, still I am giving it as a concept here. Area bounded by the parabola y square is equal to 4x and the lattice rectum is given by 8a square by 3. X equal to a is the equation of the lattice rectum. Find area in the first quadrant and double it. Okay, if you want I can give the proof of this. You can find area in the first quadrant and double it. You will get the required area. 2 times integrate from x equal to 0 to x equal to a y dx. X equal to 0 to x equal to a y dx. 2 times integral from 0 to a, y is how much? Y square is 4x. So taking the positive square root, I get y as 2 root a into root x. 4 root a is kept outside. 2 into 2 root a is 4 root a. Integral of root x is 2 by 3 x root x. Integral of root x is 2 by 3 x root x. Limits from 0 to a. Which is 8 root a divided by 3. 4 2s are 8. 8 root a. Evaluate the function at upper limit minus lower limit. Correct? This is 8 into root a into root a becomes a into a becomes a square, 8a square divided by 3. That is what we have. Area bounded by the parabola, y square is equal to 4x and its lattice rectum. Lattice rectum is x equal to a. X equal to a is the equation of the lattice rectum. Lattice rectum is the focal chord which is parallel to directrix. Focal chord is a chord which passes through the focus. So focal chord which is parallel to directrix, or the focal chord which is perpendicular to the axis is called as lattice rectum. Equation of lattice rectum. This is the lattice rectum of this. LR I can draw. LR or lattice rectum. Same way we got another result here. Area bounded by the parabola x square is equal to 4ay and its lattice rectum. Same result, 8a square by 3. If you want only in the first quadrant, you can divide by 2, you get 4a square by 3. Same story for the other one also. Only in the first quadrant you want, area is going to be 4a square by 3. The total area is 8a square by 3, both in the first and second quadrant if you include. First and the fourth quadrant. First and the fourth quadrant, area is 8a square by 3. Here, first and the second quadrant, area is 8a square by 3. Same way you can try this. Okay. Here the lattice rectum is horizontal, y is equal to a. Next we got area bounded by the lines mod x plus mod y equal to a. Mod x plus mod y equal to a represents the square region like this. Mod x plus mod y equal to a. If both x and y are positive, it becomes x plus y equal to a. Here x is negative, y is positive. So minus x plus y equal to a. Here both x and y negative is minus x plus y, minus x minus y equal to a, or x plus y equal to minus a. Both are positive means first quadrant. The line lies in the first quadrant. Both x and y are positive. Mod x becomes x, mod y becomes y, x plus y equal to a, that is lying in the first quadrant. If you want x is negative, y is positive, it lies in the second quadrant like this. X is negative, mod x becomes minus x, y is positive, mod y is y. So minus x plus y equal to second quadrant. Both x and y are negative in the third quadrant. So mod x becomes minus x, mod y becomes minus y, minus x minus y equal to, or x plus y equal to minus c. Third quadrant. Fourth quadrant we know x is positive, y is negative. So mod x becomes x, mod y is minus y, x minus y equal to e. So you can find out this area. If you want to find area in the first quadrant, multiply by 4, you get the answer. 4 times area in the first quadrant. 4 times area in the first quadrant is half into base into it. So area of triangle here. This forms a square region actually. Square region it forms. Mod x plus mod y equal to forms a square region. Okay. This is a square it is. You can check if you want. So this is a right angle triangle. So base length is a, height is also a. Half into a into a. So this is equal to how much? 4 into half is 2. 2a square. Area is 2a square. One such question is asked here. So they asked to find area bounded by the area enclosed within the curve. Mod x plus mod y equal to 1. Mod x plus mod y equal to 1 is 2a square. Mod x plus mod y equal to a is 2a square. Here 2 into 1 square. We know area enclosed by mod x plus mod y equal to a. Mod x plus mod y equal to a. Area enclosed is how much? 2 into a square. For mod x plus mod y equal to 1, mod x plus mod y equal to 1, area enclosed is 2 into 1 square, which is equal to 2. Option B. Question asked in the year 1992. Next we have area bounded between the two curves. Two curves are given, y equal to f of x and y equal to g of x. Actually this part is deleted from NCERT book. It's deleted now. There is no need to study for KCET exams, but for other competitive exams you can study. Okay, it's quite useful. Y equal to f of x and y equal to g of x. Two curves are given. You want to find area between the curve y equal to f of x and y equal to g of x, bounded by the lines x equal to a and x equal to b and x axis. You want to find this area. This area to find out. If you want to find this area, okay, this area need to find out. Find the area bounded by y equal to f of x, upper curve area minus lower curve area, f of x minus g of x. Integrate from x equal to a to x equal to b. When you integrate the curve f of x, you get this much area. When you integrate the curve y equal to z of x, you get this area. Because integration is area under the curve. So upper curve area minus lower curve area, difference of those two gives the shaded part. So integral from x equal to a to x equal to b, f of x minus g of x dx. Upper curve minus lower curve. Okay, integrate from x equal to a to x equal to b, get the answer. Similarly, we have the curve like this. X equal to f of y and x equal to g of y. Bounded between the lines y is equal to c, y equal to d and y axis. Right curve minus left curve. Right curve is this. Left curve is this. Correct? Right curve minus left curve we find out. Integrate from y is equal to c to y equal to, get the answer. Next one, we'll take the problems based on this. Area enclosed between the curves y equal to x cube and y equal to root x in square instead to find out. Question asked in the year 2004. Y equal to x cube and y equal to root x is given. Y equal to x cube, equation 1. Y is equal to root x, equation 2. From 1 and 2, left hand side is same, no? So equate the right hand sides. What do you get? X cube is equal to root x. By inspection method, I can tell x equal to 0 and 1 is going to satisfy this. Correct? 0 equal to 0 when you put x equal to 0. Even x equal to 1 satisfies. So points of intersection are when x is 0, y is 0. When x is 1, y is 1. Correct? When x is equal to 0, when x is equal to 0, y is equal to how much? 0 cube or root 0. Both same 0 only. When x is equal to 1, y is equal to 1. Correct? When x is equal to 1, y is equal to 1. So points of intersection are 0, 0 and 1, 1. So y equal to x cube is like this. Y equal to x cube. Y equal to x cube. This is y equal to x cube. And y equal to root x like this. Y equal to root x. This is y equal to root x. This is y equal to x cube. Okay. I'll represent if you want separately. This is y equal to x cube and y equal to root x. This white one is y is equal to root x. The white one is y equal to root x. And this green one is y is equal to x cube. This is y equal to x cube. We want to find this area. Okay. The white one is y is equal to root x. Y equal to x cube is the green one. Okay. We need to find the intercept at 0, 0 and 1, 1. This is the line x is equal to 1. Integrate from 0 to 1. Root x upper curve minus lower curve. When integrate from 0 to 1 y equal to root x, we get this area. This area I get. And you integrate y equal to x cube 0 to 1, I get this area. This area minus this area gives the shaded part. So required area is integral from x equal to 0 to x equal to 1. X equal to 0 to x equal to 1. Upper curve minus lower curve. Root x minus x cube. Root x minus x cube. Integral of root x is 2 by 3 x root x. Integral of x power 4, x cube is x power 4 divided by 4. Limits from 0 to 1. Correct? Upper curve minus lower curve. Integrate from 0 to 1. We get the answer. This is 2 by 3 into 1 root 1. Here 1 power 4, 1 by 4. Lower limit is 0. 3 and 4 LCM is 12. 3 4s are, 4 2s are 8. 4 3s are. So this is 5 by 12. 5 by 12 is the answer. Integrate the curve y equal to root x from 0 to 1. You get this much area. Correct? This much you get. Minus integrate the curve y equal to x cube. You get this much area from 0 to 1. This area minus this area gives the shaded part. That's the answer. 5 by 12. Question asked in the year 2004. Please make a note. Move on to the next one. Area enclosed between the parabola and the line x square minus x plus 2 and the line y equal to x plus 2 in square and it's to find out. X square minus x plus 2. You can draw the parabola and the line y equal to x plus 2. Left hand side is same, so equate the right hand sides to get the points of intersection. So from these two I can conclude that left hand side is same, no? So equate the right hand sides. What do you get? X square minus x plus 2 is equal to x plus 2. Correct? 2 cancels. So get x square minus 2x is equal to 0. Correct? So what you get is x into x minus 2 is equal to 0. Which gives x equal to 0, x is equal to 2. Points of intersection. When x is 0, y is 2. And when x is 2, y is 4. So y equal to x plus 2 also we can draw. To draw the straight line y equal to x plus 2, we need minimum 2 points. When x is equal to 0, y is equal to 2. When y is equal to 0, x is minus 2. X is 0, y is 2. Y is 0, x is minus 2. 0, comma 2 and minus 2, comma 0. 0, comma 2 is here. Correct? 0, comma 2. Minus 2, comma 0 is here. This is y is equal to x plus 2 and y equal to x square minus x plus 2. Right hand side is quadratic in x, so it represents the parabola, and coefficient of x square is positive, so it's upward parabola. And if you find d, no, b square minus 4ac for this quadratic, if you find d, that is b square minus 4ac, if you find out, how much you're going to get? B is minus 1, minus 1 square is 1, minus 4 into A is 1, C is 2. Like this we get. Correct? 1 minus 8, which is minus 7. D is negative. D is negative means the parabola will not intersect the x-axis. Okay? So y equal to, and it passes through 0, 2. When you put x equal to 0, 0, 0, 2, y is 2. So 0, 2 is a common point for both, correct? Intersecting at x equal to 0, y is equal to 2. And another point of intersection is x equal to 2, y is equal to 4. Correct? 0, 2 and 2, 4. The parabola may look like this. Something like this. 0, 2 and 2, 4 is here. So this area I need to find out. I need to find this area. I'll mark the points outside the curve so that can make out easily. Y equal to x plus 2 and y equal to like this. A rough sketch for understanding purpose. This is 0, 2. This is 2, 4. This point is 2, 4. And this point is 0, 2. This area we need to find out. Okay. The line is y is equal to x plus 2. And the parabola is y equal to x square minus x plus 2. So integrate from x equal to 0 to x equal to 2. Okay. Something like this. My curve is like this. Y is equal to a rough sketch only for understanding purpose. Okay. Integrate from x equal to 0 to x is equal to 2. Upper curve minus lower curve. Upper curve is x plus 2 minus lower curve is x square minus x plus 2. Upper curve minus lower curve. Correct? Between the lines x equal to 0 and x equal to 2. My figure is not so perfect. If you want, I can draw the better figure. Something like this. Okay. It is not intersecting the x-axis, but it is not intersecting the x-axis because b square minus 4ac is negative there. Quadratic is negative there, correct? So y is equal to, this is y equal to x plus 2, the straight line, and this parabola is y equal to x square minus x plus 2. Want to find this area. Integrate from 0 to 2. This line is x is equal to 2. X equal to 0 to x equal to. Upper curve minus lower curve, correct? X plus 2 minus 2 will cancel. What I am getting is integral from 0 to 2, correct? Plus 2 minus 2 cancels. X minus minus x, that is 2x minus x square. Integral of 2x is x square. Integral of x square is x cube divided by 3. Limits from 0 to 2. Evaluate the function. Lower limit is anyway 0. Upper limit is 2. 2 square 4. 2 cube is 8. So lower limit is 0. I won't write that. LCM is 3. 3 into 4. 12 minus 8, which is 4 by 3. 4 by 3 is answer. Question asked in the year 2006. Move on to the next one. Area bounded by the y-axis and y equal to sin x and y equal to cos x in the first quadrant, 0 to pi by 2 they ask. So y equal to sin x and y equal to cos x. In the first quadrant they intersect at x equal to pi by 4 we know. Correct? Area bounded by these two curves and y-axis they ask. Y equal to sin x in the first quadrant like this. 0, x equal to 0, sine function is 0. Sine function maximum value is 1 at x equal to pi by 2. This is y equal to sin x. y equal to cos x. Y equal to cos x is here. This is y equal to cos x. Y equal to sin x and y equal to cos x between 0 to pi by 2. Area bounded by these two and y axis. Y axis is here between this 0 to this is pi by 4. 0 to pi by 4. Integrate the curve y equal to cos x minus sin x. Integrate cos x from 0 to pi by 4 minus integrate sin x from 0 to pi by 4. Required areas. Integral from x equal to 0 to x equal to pi by 4. Cos x minus sin x. Correct? Want to find area between y equal to cos x, y equal to sin x in the interval 0 to pi by 2 bounded by the y axis. So integrate the curve y equal to cos x. This is cos x from 0 to pi by 4. Upper curve. When integrate cos x, you get this much area. When integrate sin x from 0 to pi by 4, we get this area. So this area minus this area gives this. Integral of cos x is sin x. Integral of sin is minus cos. Minus of minus plus cos x. Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. Sin pi by 4 is 1 by root 2 plus cos pi by 4 is 1 by root 2 minus sin 0 0 cos 0 is 1 1 by root 2 plus 1 by 2 by root 2 which is root 2 root 2 minus 1 root 2 minus 1 option A. Question asked there 2019. 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 is root 2 minus 1. Sin 0 0 cos 0 1. On to the next one. Area of the region above the x-axis included between the parabola and the circle in squareness. So y square is equal to x is the parabola we know. Y square equal to x is the parabola axis along x-axis. Y square is equal to x. Area bounded by this. Y square is equal to x. And the circle I can complete the square for this. I can reduce it to the form x minus h the whole square plus y minus k the whole square equal to r square. X square plus y square is equal to x. I can write x square minus 2x plus y square equal to 0. I can complete the square for this. I can write this as x minus 1 the whole square plus y minus 0 the whole square is equal to 1 square. I am completing the square for this. X minus, coefficient of x is minus 2, half into minus 2, minus 1. Complete the square and subtract 1 square 1. That minus 1 taken that side. Okay. So center is at 1 comma 0, radius is 1. Compare with x minus h the whole square plus y minus k the whole square equal to r square. Center is at 1 comma 0, radius is 1. So and also you can find the points of intersection of these two. You put y square is equal to x in the equation of circle. When you put y square is equal to x, I am going to get x square. In place of y square, you put x. So what I get? X square plus x minus 2x is equal to 0. So what I get is x square minus x is equal to 0. So x common. X into x minus 1 equal to 0. So x equal to 0, x equal to 1 are the points of intersection. And center is 1 comma 0. Correct? X equal to 0 and x equal to 1 are the points of intersection from this. So one is x equal to 0, y will be 0. When x is 1, y is 1. So 0 comma 0, correct? When x is 0, y square is 0, so y is 0. When x is 1, y square is 1, that is y equal to plus or minus 1, correct? Y square is 1 means y is plus or minus 1. So points of intersection are one is at 0 comma 0, another one is at 0 comma 1 and 0 comma minus 1. 0 comma 0 is original, 0 comma 1 is here, 0 comma minus 1 is here, center is 1 comma 0, correct, for the circle. Something like this. Center is at 1 comma 0, passes through these points, 0 comma 1 and 0 comma minus 1. Circle is passing through these points. Like this we get a rough sketch. Center is 1 comma 0, radius is 1, passes through the points 0 comma 1 and 0 comma minus 1, correct? Points of intersection are circle is and the parabola are intersecting at x equal to 0, correct? Y square is equal to x square minus x equal to 0, x into x minus 1 0, x equal to 0, y equal to 0. When x equal to 1, when x equal 0, not 0 comma 1, sorry, plus 1 plus or minus 1 comma 0, this is x equal to 0 and x equal to plus or minus 1, correct? When x is 0, y is 0. When x is 1, y square is 1, so y is plus or minus 1, so 1 comma plus or minus 1. When x is 1, correct, y square is 1, y square 1 is y is plus or minus 1. So 0 comma 0 is one point of intersection, and then the point is 1 comma plus or minus 1. This is the point. This is 1 comma 1 and this is 1 comma minus 1 points of intersection. These points are not required. This is not guaranteed points. Correct? This is how it looks. Points of intersection are 1 comma 1 and 1 comma minus 1, because when you put y square is equal to x, I get x square plus x minus 2x equal to 0. So x square minus x equal to 0, x into x minus 1 0. When x is 0, y is 0, 1 point we get 0 comma 0. When x is 1, substitute y square is 1, y square 1 is y is plus or minus 1. So points of intersection are 0 comma 0, 1 comma 1 and 1 comma minus 1. Want to find area of the region above the x-axis included between the parabola and the line. So parabola and the circle. So included between the parabola and the circle is this. You want to find that part. Okay. So integrate from 0 to 1, upper curve minus lower curve. Required area is integral from 0 to 1, 0 to 1, upper curve minus lower curve. That is area of the circle minus area of the parabola. Correct? Circle is what? Circle you can write y square is equal to x minus 1 the whole square plus y square equal to 1. Now from this we can write it as what? Y square is equal to 1 minus x minus 1 the whole square. Correct? Y square, from this equation I can write it as y square is equal to 1 minus of x minus 1 the whole square. So y is equal to what? Root of 1 minus of x minus 1 the whole square, taking the positive square root. Correct? So we get root of 1 minus of x minus 1 the whole square of the circle. This is circle minus the parabola. Area of circle from 0 to 1, you get this much, minus the parabola from 0 to 1. Y square is x, so y is root x. Integrate this and get the answer. Integral of root of a square minus x square form, x by 2 into root of a square minus x square plus a square by 2 sin inverse of x square. That formula I am using here. Correct? So for this it will be x minus 1 by 2 into root of 1 minus of x minus 1 the whole square plus a square by 2 sin inverse of x by a. Limits from 0 to 1. Integral of root x is 2 by 3 into x root x. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. When you put x equal to 1, see 1 minus 1, 0, 0 into this 0. When you put upper limit x equal to 1, 1 minus 1, 0. Upper limit both the terms are 0. When you put x equal to 1, 1 minus 1, 0. 1 minus 1, 0. So upper limit becomes 0. Minus lower limit. When you put x equal to 0 here, 0 minus 1 is minus 1, minus 1 square is 1, 1 minus 1, 0, this part is 0. When you put upper limit, this term becomes 0. When you put lower limit also, this term becomes 0. When you put x equal to 0, 0 minus 1 is minus 1, minus 1 square is 1, 1 minus 1, 0. For lower limit, this term is becoming 0. For lower limit, this term is how much? So, I am getting 0 minus 1, minus 1, sin inverse of minus 1, which is minus pi by 2, correct? So, minus of half into sin inverse of minus 1 I am getting. Half into lower limit is for x equal to this term minus upper limit minus lower limit. So minus of sin inverse of half into sin inverse of 0 minus 1 is minus 1 minus 2 by 3 into upper limit 1 root 1, which is 1, minus 0. So this is minus half into sin inverse of minus 1 is minus pi by 2, and this is minus 2 by 3. So this becomes how much? Pi by 4 minus 2 by 3. Correct? Pi by 4 minus 2 by 3. Minus into minus plus. Pi by 4 minus 2 by 3 square units. Question asked in the year 2019. Please make a note. Move on to the next question. Question number 5 we have. Area of the figure bounded by the curves y equal to cos x and y equal to sin x, and the ordinates x equal to 0 and x equal to pi by 4. So we'll draw the curve y equal to cos x as well as y is equal to sin x in the interval 0 to pi by 4. Sin x is increasing function in the interval 0 to pi by 2. Sin 0, 0. Sin pi by 2 is 1. Goes up like this. Cos a decreasing function, correct? In the interval 0 to pi by 2. This is y is equal to sin x. Maximum value is 1. Correct? This is pi by 2. This is y is equal to cos x. Want to find area bounded between these two curves, y equal to cos x and y equal to sin x, between x equal to 0 and pi by 4. They intersect at pi by 4. Correct? At pi by 4, we know that cos function and sin function become equal at x equal to pi by 4. Sin pi by 4 is 1 by root 2. Even cos pi by 4 is 1 by root 2. Area between these two is bounded by this part. Correct? So we need to find integral from 0 to pi by 4. This is upper curve minus lower curve. Upper curve is cos x minus lower curve is sin x. Integrate cos x from 0 to pi by 4, we get this part. Integrate sin x from 0 to pi by 4, this part. Difference of those two gives the shaded part. When integrate the function y equal to cos x from 0 to pi by 4, we'll get this much. And when you integrate y equal to sin x from 0 to pi by 4, we get this part. Difference of those two is shaded part, correct? So required area is integral from x equal to 0 to x equal to pi by 4, cos x minus sin x dx. Integral of cos x is sin x. Integral of sin is minus cos. Evaluate the function at upper limit minus lower limit. This is sin x, minus of minus becomes plus. Sin pi by 4 is 1 by root 2 plus cos pi by 4 is also 1 by root 2. Evaluate the function at upper limit minus evaluate the function at lower limit. Sin 0 is 0. Minus of minus plus, cos 0 is 1, 1 by root 2 plus 1 by root 2 is 2 by root 2 minus 1, 2 by root 2 is root 2 minus 1, square units. Option A is the answer. Question asked in the year CET 2002. Question asked in the year 2002. Hope it's clear. We need to find area between the two curves from in the interval 0 to pi by 4. This question is similar to the earlier one we did. There they asked to find 0 to pi by 2 was the interval, but still they get bounded in the interval 0 to pi by 4 with y-axis. Correct? With y-axis they get bounded, sin and cos, in the interval 0 to pi by 4. So this is a required relation. Integrate from 0 to pi by 4, upper curve minus lower curve. Cos x minus sin x. When you integrate cos x from 0 to pi by 4, we get this much area. This area we get. Minus, when you integrate the sin x function from 0 to pi 4, we get this. This area minus this area gives the shaded part. Hope it's clear. In the interval 0 to pi by 2, area between the curves y equal tan x and y equal to cot x and x axis. So in the first quadrant, we need to find area between y equal to tan x and y equal to cot x. We know tan x and cot x in the first quadrant will intersect at x equal to pi by 4 because tan pi by 4 is 1. Even cot pi by 4 is 1. Correct? Tan function is increasing in the first quadrant. 0 to pi by 2, it increases like this, goes up. And cot function is decreasing from infinity to 0. Like this. Correct? It decreases. Want to find area between y equal to and the intersect at x equal to pi by 4. Find this area and this area. Want to find this area and this area. Correct? This is y equal to tan x. This curve is y is equal to tan x. And this is y equal to cot x. So integrate from where to where? 0 to pi by 4. X equal to 0 to x equal to pi by 4. This is of tan x. Pi by 4 to pi by 2 is of cot x. Correct? 0 to pi by 4 tan x and pi by 4 to pi by 2 which is cot x. Integral of tan x is log of mod secant x. Limits from 0 to pi by 4. Integral of cot x is log of mod sin x. Limits from pi by 4 to pi by 2. Log of mod secant pi by 4 minus log of mod secant 0. Here log of mod sin pi by 2 minus log of mod sin pi by 4. Secant pi by 4 is root 2. Secant 0 is 1. Sin pi by 2 is 1. Sin pi by 4 is 1 by root 2. Correct? Secant 0 is 1. Sin pi by 2 is 1. Log 1 is 0. Log root 2 and here minus log 1 by root 2. This is 0. Log 1 is 0. What I am getting is log root 2. Log 1 by root 2 is minus log root 2 because you know that log 1 by a is minus log a. Log 1 by a is equal to minus log a. So log 1 by root 2 is minus log root 2. Minus of minus plus log root 2. Log root 2 plus log root 2 becomes 2 log root 2. And you know property of log, b log a is log a power b. Correct? b log a is log a to the power b. Correct? So this 2 goes to the power. This becomes log of root 2 b square, which is equal to log 2. Log 2 square roots. Integrate from 0 to pi by 4 tan x. Get area under the curve of tan function. 0 to pi by tan function is increasing, going up. Cot function is decreasing. 0 to pi by 4 tan x. Pi by 4 to pi by 2 cot x. Integral of tan is log of mod secant x. Integral of cot x log of mod sin x. Integrate from upper limit, evaluate the function upper limit minus lower limit. Get the answer. Log 2 is the answer. Question asked in the year 2023. On to the next one. Area of the region bounded by the line y equal to x and y equal to x cube we have to find out. Y equal to x is straight line passing through the origin. Y equal to x. Straight line passing through the origin, which bisects the first and third quadrant. Y equal to x. Y equal to x cube. Y equal to x cube is this. Y equal to x cube. Want to find this area. Find area in the first quadrant and double it. Both the areas are equal because of symmetry. And they intersect at 0, 0 and 1, 0 and also at minus 1, 0 I think. minus 1 comma minus 1, correct? 0 comma 0, 1 comma 1 and minus 1 comma minus 1. Y equal to x, y equal to x cube. Solve the two equations. Y equal to x, y equal to x cube. From 1 into, left hand side is same, so equate the right hand sides. X cube is equal to x. X cube equal to x means x cube minus x equal to 0. So we can take x common. So we get x square minus 1 equal to 0. A into B 0 means either A equal to 0 or B equal to 0. X equal to 0, your x square equal to 1. X square equal to 1 means x is equal to plus or minus 1. When x is 0, y is 0. Correct? Points of intersection. When x is 0, y is 0. When x is 1, y is 1. When x is minus 1, y is minus 1. Correct? Points of intersection are, one is at origin, another this point, that is 1 comma 1. Correct? Another point is here, minus 1 comma minus 1. Points of intersection. So we need to find area in the first quadrant and double it. So required area is 2 times integral from x equal to 0 to x equal to 1. X equal to 0 to x equal to 1. Upper curve minus lower curve. Upper curve is y equal to x minus lower curve is x cube. Correct? Upper curve minus lower curve. Integrate the line y equal to x from 0 to 1. So vertical line I can call x equal to 1 here. 0 to 1 integrate the line, you get this area. Minus 0 to 1 integrate the curve y equal to x cube. Line minus curve gives the shaded part. Correct? 2 times. Integral of x is x square divided by 2. Integral of x cube is x power 4 divided by 4. Limits from 0 to 1. 2 into. Evaluate the function. Upper limit. Lower limit is anyway 0. 0 square 0. 0 power 4 0. Only upper limit will put right. 1 by 2 minus 1 by 4. 2 times. 1 by 2 minus 1 by 4 is 1 by 4. 2 into 1 by 4 is half. Half is 0.5. Option D. Question asked in the year 2024. Move on to the next one. Area bounded between the parabola y square is equal to 4x and the line y equal to 2x minus 4. Y square is equal to 4x is a parabola having vertex at origin symmetric with respect to x-axis. And also you can represent y equal to 2x minus 4. The axis along x-axis for y square is equal to 4x. And also will represent the line y is equal to 2x minus 4. To draw the straight line we require minimum 2 points. Correct? When x equal to 0 find y equal to how much? When y equal to 0 find x equal to how much? To draw the straight line y is equal to 2x minus 4. X, y. When x is 0, 2 into 0, 0, 0 minus 4, minus 4. When y is 0, x is 2. Correct? When you put x equal to 0, y is minus 4. When y is equal to 0, x is 2. So 2 comma 0 and minus 0 comma minus 4 points on the line. 2 comma 0 is here. Correct? 2 comma 0 and 0 comma minus 4 on the negative y-axis. 0 comma minus 4. Join these 2 points. We'll get a straight line like this. Correct? This is y square is equal to 4x. And the line is y is equal to 2x minus 4. The line is y is equal to 2x minus 4. So we need to find area between the parabola and the line. So area bounded is this. This area I need to find out. Get the points of intersection. Solve the two equations. Put y is equal to 2x minus 4 in the equation of parabola. Put y is equal to 2x minus 4. Put y equal to 2x minus 4 in y square is equal to 4x. What we get? 2x minus 4 the whole square is equal to 4x. Putting y as 2x minus 4. Expand this. 2x minus 4 the whole square. 4x square plus 16 minus 2ab. 2 into 2, 4. 4 4s are 16. 16x minus 4x is equal to 0. Writing all the terms to one side. So what do you get? 4x square minus 20x plus 16 equal to 0. Divide the entire equation by 4. We get x square minus 5x plus 4 equal to 0. Factorize this. X minus 1 into x minus 4 equal to 0. Gives x equal to 1, x equal to 4. x equal to 1, x equal to 4. When x equal to 1, find the corresponding value of y. When x equal to 1, when x is equal to 1, y is equal to how much? Y is 2x minus 4, correct? 2 minus 4, which is minus 2. When x equal to 4, upper limit, when x equal to 4, y is equal to 2x minus 4, 2 into 4, 2 into 4, 8. 8 minus 4 is equal to 4. So this point is x is equal to 1, y is equal to minus 2. And this point is x equal to 4, y equal to 4. This point is 4 comma 4. This point. And this point is x is equal to 1, y is equal to minus 2. Correct? So points of intersection. If you draw the horizontal line here, this line is y is equal to minus 2. If you draw the horizontal line here, this line is y is equal to 4. Correct? So I'll use the y lines and find the area. So you can view like this. Integrate the line minus integrate the curve. Right curve minus left curve. Correct? Required area is integrate from y is equal to minus 2 to y is equal to 4. Y is equal to minus 2 to y is equal to 4. Right curve minus left curve using function of y. So x is how much? From y is equal to 2x minus 4. X is y plus 4 divided by 2. Correct? Y plus 4 divided by 2 with respect to y. Minus y is equal to minus 2 to y is equal to 4. Find out x from the curve. X is y square by 4 because I need to express as a function of y because I am using y lines. Formula is x dy. X is y square by 4. Y square divided by 4. Integrate this. Get the answer. Divided by 2 means keep 1 by 2 outside. Integral of y is y square divided by 2. Integral of 4 is 4y. Limits from minus 2 to 4. Integral of y square is y cube by 3. Y cube by 3 by 4 becomes y cube by 12. Y cube divided by 12. Limits from minus 2 to 4. Correct? Y cube by 3 by 4. Y cube by 12. 3 comes to denominator. Gets multiplied. So we get simplify. Find out the value. Evaluate the function at upper limit minus lower limit. We'll get the answer. We get half into upper limit how much? 4 square 16. 2 square 4. 16 minus 4 by 2. Correct? 16 minus 4 divided by 2. Here 4 into 4 plus 2, 6. 1 by 12 into 4 cube is 64 minus 2 cube is minus 8. Correct? Upper limit minus 4 square 16 minus 2 square 4. 16 minus 4 12. So I'll write the answer here. Required area is half into what we get here is 16 minus 4 12. 12 by 2 is 6. 4 into 6 is 24 minus 1 by 12 into 64 plus 8 is 72. Correct? This is 30 by 2, 15. This is 72 by 12, that is 6. So answer is 9. 9 square units. Little bit lengthy for CET exam, but can be asked these kind of questions. Please make a note. Using horizontal lines, using y lines, integrating the right curve minus left curve. Correct? Integrate the line minus integrate the parabola. Expressed in terms of y because I'm using the formula f of y, function of y because y lines are used. So f of y minus z of y, right curve minus left curve. On to the next one. Next we have area between the parabola and the line y equal to mx. The time saving result we have for this. Area between the parabola y square equal to 4x and y equal to mx. Y equal to mx is straight line passing through origin. This area you want to find, it is 8a square by 3m cube. Please learn this formula. Area between the parabola y square is equal to 4x and y equal to mx is 8a square by 3m cube. Time saving result. Similar type of time saving result we have for x square is equal to 4ay and y equal to mx. Area bounded is 8a square m cube by 3. Here m cube in the numerator. There m cube in the denominator. That's the difference. Here m cube is in the denominator. Here m cube in the numerator. Okay. So there are some problems based on this. We'll work out. Area of the region bounded by the parabola and the line. Y square is equal to 8x and y equal to x. You can do the traditional method also. We'll get the answer. I'll show that also. I'll do by shortcut method, time saving result also. Both the methods will do. Y square is equal to 8x and y is equal to 2x. If you're doing the time saving result, using time saving result, compare this with y square is equal to 4x. This will compare with y is equal to mx. Okay. Y square is equal to 4x. If we compare, I'll get 4a is equal to 8. 4a is equal to 8 means a is equal to 2. Here m is equal to 2. What is area between y square is equal to 4x and y equal to mx? 8a square by 3m cube. 8a square divided by 3m cube. 8 into a is 2 square divided by 3 into m is 2 cube. 2 cube is 8 cancels. 2 square is 4 by 3 is answer. 4 by 3. Question asked in the year 2020. If I'm doing the actual method, I can draw the curve y square is equal to 8x. Y square is equal to 8x is a parabola. Opening right side. Opening on the right. Axis along x axis. Correct? Vertex at origin. Y equal to x is a straight line passing through the origin like this. Y equal to x and y square is equal to 4x. Y square is 8x. Y square is equal to 8x and this is the line y is equal to 2x. You can find the points of intersection. So substitute y equal to x in the equation of parabola. You're doing the second method, okay? If you're doing the second method, y is equal to 2x, you substitute. Put y is equal to 2x in y square is equal to 8x. Put y is equal to x. 2x the whole square is 4x square minus 8x equal to 0. 4x common, x minus 2 equal to 0. 4 is not equal to 0. Either x equal to 0 or x equal to 2. Correct? When x is 0, y is 0. When x is 2, y square is 16. So y equal to plus or minus 4 I'll get. Correct? When x is 0, y is equal to how much? Y is equal to 2x. Y is equal to 2 into 0, 0. When x is equal to 2, y is equal to 4. So points of intersection are 0, 0 and 2, 4. This line is x is equal to 2 then. This point is 2, 0 here. This point is 2, 4 here. Correct? Integrate from 0 to 2. Integrate the curve minus integrate the parabola. Integrate from 0 to 2. 0 to 2. Integrate the curve minus integrate the line. Upper curve minus lower curve. Correct? Integrate the parabola, we get this area. Minus integrate the line, we get this area. Difference of those two gives the shaded part. Y is how much from the parabola? Root 8 into root x. Root 8 into root x dx. Minus 0 to 2. Line is y is equal to 2x. Root 8 is 2 root 2. Integral of root x is 2 by 3 x root x. Limits from 0 to 2. Integral of 2x is x square. 0 to 2. Correct? Lower limit is anyway 0 for both the terms. Upper limit how much? This is 4 root 2 by 3. 4 root 2 divided by 3 into 2 root 2. And for this term it becomes 2 square is 4. 4 2s are 8. 8 into 2. 16 by 3 minus 4. I'll get 16 by 3 minus 4, correct? 4 2s are 8. Root 2 into root 2 is 2. 2 into 2, 4. 4 into 4. 16 by 3 minus 4. Take LCM 3. How much you get? 16 minus 12, which is 4 by 3. You can do this method also. Or this is the time saving result. Directly 8a square by 3m cube. Area between y square is equal to 4x and y equal to mx. 8a square divided by 3m cube. Learn this time saving result. Okay. Move on to the next one. Here also we have area lying between y square equal to x and y equal to x. I'll do the time saving result to save the time, not do the actual method. One problem I done, both the methods, so that you can understand. Y square is equal to 4ax, and here it is y is equal to mx. So if we compare, 4a is 2, correct? 4a is equal to 2, that means a is equal to 2 by 4, which is 1 by 2. Here m is equal to 1, correct? So area bounded is how much? 8a square divided by 3m cube. 8 into a is half square divided by 3 into m cube, 1 cube, m is 1. 8 into 1 by 4 divided by 3 into 1, 3. 8 into 1 by 4 is 2. 2 by 3. 2 by 3 square units. On to the next one. We have area of the region bounded by the line y equal to 3x and y equal to x square. Y equal to x square is same as x square is equal to y. X square is equal to y. Compare this with x square is equal to 4ay. So what you get is 4a is equal to 1. 4a1 means a equal to 1 by 4. And y equal to 3x. Y equal to 3x. We compare with y is equal to mx. We get m is equal to 3. Area between x square is equal to 4ay and y equal to mx is what? 8a square m cube by 3. Required area is 8a square m cube divided by 3. M cube in the numerator for this. For x square is equal to 4ay, m cube in the numerator. For y square is equal to 4x, m cube in the denominator. That's the difference. Substitute the values. 8 into a is 1 by 4. 1 by 4 square, 1 by 16. M is 3. 3 cube is 27. Divided by 3. 8 ones are 8 twos are. Correct? 3 ones are 3 nines are. Correct? 9 by 2 we get. This 16 comes down. We get 8 into 27 divided by 16 into 3. Correct? 8 ones are 8 twos are. Denominator becomes 2. 3 ones are 3 nines are. 9 by 2. Option B. Question asked in the year 2024. See the difference between this. Here x square is equal to 4ay and y equal to mx. Area bounded is 8a square m cube by 3. If it is y square is equal to 4x and y equal to mx, area bounded is 8a square divided by 3m cube. For these two problems we had m cube in the denominator because it was y square is equal to 4x and y equal to mx. Correct? Here also. Y square is equal to 4x and y equal to mx. 8a square by 3m cube. Whereas here in this problem we have x square is equal to 4ay and y equal to mx. Area bounded is 8a square m cube by 3. That's the difference. Next we have area between the two parabolas. Y square is equal to 4x and x square is equal to 4by. Both in the standard form. One has axis along x axis, another has axis along y axis. Okay. In that case, area bounded is, remember, coefficient of x into coefficient of y by 3. Just remember, see, coefficient of x is 4a, coefficient of y is 4b. So coefficient of x into coefficient of y divided by 3. That's it. Area between the two parabolas, both in standard form. One has axis along x axis, another has axis along y axis. What is area? Just to remember, coefficient of x into coefficient of y divided by 3. So we get 4a into 4b by 3, 16ab by 3. Same type of result we have here. Y square is equal to 4x and x square is equal to 4ay. How to remember? Coefficient of x into coefficient of y divided by 3. Area is what? Coefficient of x into coefficient of y divided by 3. Coefficient of x into coefficient of y divided by 3. Coefficient of x is 4a. Coefficient of y is 4a. 4a into 4 is 16a square by 3. Here we have some questions. Y equal to x square and x equal to y square. Y equal to x square means you can write it as x square is equal to y. Correct? And x equal to y square is same as y square is equal to x. So area between the two parabolas is what? coefficient of x into coefficient of y divided by 3. Just learn this, okay? Time saving result. Coefficient of x into coefficient of y divided by 3. Coefficient of x is 1 here. Coefficient of y is 1. So we get 1 into 1 divided by 3. 1 by 3 answer. Question asked there, 2014. Move on to the next one. We have area between y equal to mx square and x equal to my square is given as 1 by 4 square means. Want to find the value of m. Y equal to mx square. Y equal to mx square and x is equal to my square. You can write this as x square is equal to what? X square is 1 by m into y. Here y square is equal to 1 by m into x. Correct? Rewrite this. X square is 1 by m into y square is 1 by m into x. Area between the two parabolas, we know coefficient of x into coefficient of y divided by 3. Coefficient of x into coefficient of y divided by 3. Area is already given to be equal to 1 by 4. Area is given as 1 by 4. What is coefficient of x? Coefficient of x is 1 by m. Coefficient of y is also 1 by m. Divided by 3. Cross multiply this. We get 3 by 4. Correct? 3 by 4 is equal to 1 by m square. Take reciprocals. M square is 4 by 3. M square is 4 by 3. M is plus or minus 2 by root 3. I think there is a mistake here. Plus or minus 2 by root 3 it is. Plus or minus 2 by root 3. Area between the two parabolas is given to be equal to 1 by 4. Area is, we know, between the two parabolas is coefficient of x into coefficient of y by 3. Coefficient of x is 1 by m. Coefficient of y also 1 by m. 1 by m into 1 by m by 3. This 3 cross multiply. 3 by 4 equal to 1 by m square. Take reciprocal. M square is 4 by 3. M is plus or minus 2 by root 3. Small error in typing. Plus or minus 2 by root 3. Question asked in the year 2011. Please make a note. On to the next one. Here also we have area enclosed between the curves. Y square is equal to 4x and x square equal to 4y. Coefficient of x into coefficient of y by 3. Required area is coefficient of x is 4. Coefficient of y is 4. 4 into 4. 16 by 3. Area is 16 by 3. Option B. Coefficient of x into coefficient of y divided by 3. Area include between these two also. Coefficient of x into coefficient of y by 16 by 3. Correct? Question asked in the year 2003. This all the questions we have completed. Okay. Of application of integrals. Okay. There is a small mistake, I think. Plus or minus 2 by root 3. Correct? No. Coefficient of x into coefficient of y divided by 3 is given to be equal to 1 by 4. 3 is cross multiplied. 3 by 4 equal to 1 by m square. Take reciprocal. M square is 4 by 3. M is plus or minus 2 by root 3. Okay. All the questions we have completely solved. Okay. And also you can remember the point of intersection is 4e, 4e here. All the questions have been solved. We had totally 45 or 46 questions. Some questions are repeated. Totally we had 51 questions. Okay. All the questions we have completed. Also, I drawn the graphs of various things. Okay. Many more videos will be uploaded in the coming days. Continuing with this series, KCET series of PYQs, okay, 1984 2025, or various other chapters will be uploaded. Please subscribe to my channel and forward to your friends. With this, I conclude. Thank you.